was out, but they just keep drawing me back in. I told them I don't do electronics for hire anymore. Now I'm all about the content, but they sometimes the world just won't listen. This is it. One last job, and then I'm out. I promise, I'm out. Ladies, gentlemen, cyborgs, friends, family, everybody, how's it going? Welcome back to Voidstar Labs. Well, wait, there's only one lab. Welcome to Voidstar Lab in its original form. That's right. Back a long time ago, almost an entire year at this point. Before I was, the video making internet funny man that you see before you, I built electronics for clients. Yep, I was a freelance product developer and prototyper, and people would come to me with ideas for their stuff, and I'd make it happen. And hair's got this I think from wearing this heads up display so often, it's like put a permanent divot in my hair. Look at that, it's like a notch on it. Anyways, people would take their great ideas to me, and I would explain to them politely why they're not that great, and they pay me for it. But it wasn't just about the. It wasn't just about the startup people and the corporate types. There was also a lot of artists. A lot of artists would come up with these great ideas involving mixing technology and I need a synonym for art, but I can't think of one. And they would come to me because they realized that the technology part is a little bit harder than they anticipated. And those, in my opinion, were the best jobs because I got to do all kinds of neat stuff. Some combination of there's always some combination of something exciting I've never done before and something straightforward that I've done a million times. And this is a long-winded way of saying that I went from being the prototype developer guy to being the YouTube guy really quickly. Within the first 3 episodes, I knew that this channel was a project worth doing. And I still had a couple clients, and I got rid of I don't want to say got rid of because that doesn't sound very nice, but I finished most of those jobs while finishing the first videos. But there was one left. There was one artist who had commissioned me to build. We'll explain in a sec, but she commissioned me to build a very simple but straightforward piece of a straightforward but interesting piece of technology. And, when I told her the situation, she didn't want to cancel because the project is for a gallery. The gallery was closed because it was a pandemic, but now the gallery is going to reopen. And I'm in a bit of a pickle, because I've got, we're approaching 225,000 subscribers, and, I still have a job to do. So that's what we're going to be doing today. This has a high chance of being the very last project that I ever do as a commission. This could be the very last, I did this job for almost a decade before switching to YouTube, and this could be it. There's a pretty high chance that this is the very last project I ever make as a commission. Yeah, I do sponsored videos, but they're not commissioning the project. They're commissioning the video. And designing something for a client is significantly different from designing something for myself, especially under the restrictions and the stuff for YouTube. Anyways, I don't want to get too deep into the weeds, but that's the introduction for today. This has a high chance of being the very last client project. And yeah, this was the job, I've never really had another job, right? Yeah, sure, I had some work study things in college, but basically from the time I graduated until the time I started, until the time I hit a few thousand subscribers, I've been a freelance product development person. I've been a freelance prototyper. And, This is it. There's one job left. So let's do let's do our first few orders of business. As is, sorry. There's been a lot to do lately. I've been very tired. Not to mention that I got woken up early all last week as they were repairing the wall. I'm sorry I had to cancel that last stream at the last second. Normally I'd prefer to do it with a few days' notice, but I thought they'd be finished by Friday, but it wasn't quite there. So let's do this. All right. First step, of course, is to log into the shelves and turn them on. Come on, shelves. I realized what the problem is with the shelves. I used a linear. There it is. I used a linear regulator to convert the 12 volts for the shelves down to 5 volts, or down to 3 volts for the ESP8266, and I thought it wouldn't be a lot. I thought that wouldn't be a lot of heat because the ESP8266 doesn't draw that much heat. Like, it doesn't draw that much power. But still, like, dropping what is that, 8.7 volts, like, that's a lot of heat, even if it's only dropping even if it's only, 50 milliamps or something. But, yeah, anyways, maybe we'll fix that later. But, yeah, today we're going to be doing the last client project. A project, possibly the last client. Let's explain what this is. I don't like how I put here mandala spinner, but that's not going to make a lot of sense. So let's change this to something that is a little less pretentious. Here we go. It's motorized art. So basically, this artist here. I'm actually going to switch you over to my screen here. Yeah, so let's show you who I'm building this for. I'm building this for Pauline Galliana, who is a mixed media artist based in New York City, and her pieces are really colorful, and like I love colorful stuff, and they combine. Here, there we go. That's all right. So her pieces are really colorful, and they combine sort of traditional media with like modern manufactured objects, and it's really cool. So the pieces the pieces that I'm helping her with are a bit of a different style. Basically, they're influenced by this piece right here is sort of the starting point. They're based off of mandala, a circular piece that kind of evokes the circle of the circle of life. But these are mixed media pieces built on a large disc around a meter in diameter. I think some of them are actually a little bigger. That's semi-transparent, also has stuff on it. And she wants the piece to slowly turn throughout the day. Not continuously either. The whole idea is that she wants the piece to be in a slightly different orientation whenever someone goes back to look at it. And these pieces are going to be in a So these pieces are going to be in a gallery, and there's also a chance that she'll sell them afterwards. There's a high chance. So they need to work on their own without any sort of maintenance for about a month. They have to be able to run for about a month straight without running out of power. They also they need to be. We can't plug them into a wall, right? Because it'll look weird, and it'll look a little weird. And the battery also has to be rechargeable by a person who has, I can't make a custom battery pack that needs to be, plugged into a barrel jack or something, or plugged into a lithium charger. This needs to be something super simple that really anyone can do. It also has to be silent, because, sure, it doesn't have to move very fast, so it's not hard to make a very quiet piece of, very quiet motorized item. But it has to be really quiet, because in the gallery there are going to be 20 of these things. And if they're making sound, it's going to stack up and you're going to hear it. We also have to... if possible, I have to add in some provision to make sure that they're as different as possible. Not random per se, but different. So figure that out. So this project has already... So I've already prototyped this project. And I'm trying to think if there's a way to I probably should have found my... So, like, I stripped the prototype down for... isn't this neat? These are all, like, little ribbons. I stripped the project down for to work on it. I probably should have found the image ahead of time. I think I had it on YouTube, but I deleted it. Let me head into YouTube real quick to see if there's to see if it's still up. Because I was So here's the stage this project is at. I've already done a prototype. And the prototype, and like I've already partially adapted the prototype. She wants to have 20 of these things, and the prototype is way too like I'll show you what I've made so far, but the prototype is way overkill. Let's see. This is going to be way back then because this thing I started working on it before I uploaded almost any videos. I think I deleted it. It's too bad. Yeah, I think I uploaded it. I briefly did this podcast with through a Google Glass. And it's terrible. It's one of those pretentious things ever. It sucks. That's what's cluttering up my list here. All right. Well, here's the plan. So here's the plan. I'm going to show you what we're working on. Then I've got I think all the way through designing a circuit board for it, but I'm not sure. I just designed it. We're going to go back and double check it, make sure everything is good. Then we're going to export it, right? And we're actually going to order a circuit board. We'll try to do that without me leaking too much personal information. But I think we're going to go on Osh Park and actually order some circuit boards, which I think is going to be kind of interesting. It's not as interesting as designing the circuit board from scratch, but I think it's fairly close. The board is simple, you'll see. Then I've ordered a few parts, but I haven't tested them yet. In particular, there's one element that I have to make sure is going to work. Because of logistics here, I generally order parts. Sometimes you gotta order parts before you know they're going to work, and that's the case here. So here's the issue. I'll loop back in this sec. Let's finish the job here. So we need to design and 3D print a frame to hold all this stuff. It has to be well balanced enough that it doesn't like have too much torque on it. Remember, this thing is quite heavy, so we have to keep it as close to the wall as possible, and to reduce the moment of inertia. And we also have to make sure it's possible to access this. So basically, this is a large plastic disc mounted on a stepper motor, and we need to both design the thing that sticks the stepper motor to the wall, and also we're going to need some sort of detachable spindle thing so that it's easy to remove the disc so you can pull the battery out of it. The battery is a USB battery pack, and we have to be able to remove the disc so that we can pull the battery pack out and charge it. And if possible, I'd like to add some provision to hang the disc so you don't have to put it on the floor while you're charging it. We're also going to need something to keep it attached that you can remove without any tools, because we can't have any exposed hardware. It's not going to look good. So we're going to do that. Hopefully we can. We. And actually print one. We'll see. I kind of doubt it. Maybe I'll use this as a pretense to set up one of my printers for like high speed printing. Take the volcano in the tool changer and put in like the 0.8mm nozzle and really like try to open it up, see how fast we can print. If possible, I'd like to if we do get that printed. Honestly, though, even if we don't, we'll take the prototype we already have, and if possible, I'd like to actually set it up. We're going to screw it into the wall here. Don't tell the leasing office. Shh. And we'll work on the code a little bit. The code needs a little bit of work, and we also have to perform that test. So we're going to be setting this thing up anyways. And then finally, it's possible. Like, I don't actually know how long these things are going to take, because a lot of the work for these has already been done, but there's a chance all the work's already been done, so there's both a chance that we'll finish this fast, and also a chance that will take a little too long. If we finish this quickly, that's why I put the redacted in there. We have some interesting stuff to show off. I've been sent a lot of neat stuff, and I'd like to show some of it off. This is a bit of an, just full disclosure, this is a bit of an awkward, the stream is going to be a little awkward, because I had to settle on the topic at the last second. I'm almost done working on the next episode, and I had hoped to finish it by now, so that's on my mind. But also, we're kind of this awkward stage, because the next few videos don't involve, that's the way of saying it. So the next few videos involve printing a lot of boats. We have a lot of code to write. I have a piece of electronics that needs some pretty interesting programming, but none of that stuff is really, we can't really put on a stream, and we're not quite at the stage where we're going to be working on the next stream project. The next stream project is going to be pretty neat. We'll explain. It's going to be great. We'll explain that in a sec. This is kind of a warm up for that. So as for testing the components, like this is going to be kind of interesting. So here's. Let me show you around. Let's come into my office here. Let's come into my office. Let me show you around. I set up. So let's switch to the overhead view. So I actually rustled up this tablet here, and the idea was to set that up so I have an extra, basically as an extra monitor, so I don't miss any of your comments. But I didn't have a chance to do that because this is the slowest tablet on Earth. This is a Windows tablet that runs. Oh, come on! I don't even remember what password I used in this. Yeah, this is a Windows tablet that runs like it's like the slowest Windows tablet. It's like it's the only. I believe it's the only Windows. I think it's the thinnest and lightest Windows tablet device, and it has this wimpy, Intel Atom processor. I can't remember what password I used for this. Let's see. What happens if I click I forgot my PIN? Is it gonna have me delete the operating system or something? Basically, the idea is to use this thing to look at the comments or to look at, Discord chat or something, so I don't miss when people are commenting, because every once in a while, why does it say just a moment? This thing is super slow. I'm not even going to bother with it. I think it blew it. I think it missed its chance. So, oh man, there's a lot of interesting stuff here. Yeah, I rearranged the furniture a little, so you can see that now I've got the parts bin, I've got the tool bin behind me, which is going to add a little bit of visual flavor. But the reason I did that, the reason my Microsoft account doesn't exist, please enter a different account. You know what? I'm going to fold this thing up so it doesn't distract me. We're going to deal with this later. It's telling me that my account doesn't exist, which I'm sure is not going to cause any sort of problems and doesn't indicate any sort of larger issue. So, check this out. Alright, so this part you've seen before. Oh, by the way, today's Mio is called Green Thunder. It's Green Thunder flavored. It's, I think, melon. Yeah, Green Thunder. That's what I want my, if I run a frat, that's what I want my mug name to be. Green Thunder. So check this out. Continuing on. Aw, look at this. We have a side table here. We've got the tool changer is probably not going to stay up here. Tool changer is probably going to move. But yeah, we've got the laser cutter now as a home. The Anycubic Viper. This thing might be switched with a Prusa or a resin printer. And we've got the tool changer up here. Because, remember how I've been struggling to figure out, how to stream... I've been struggling to figure out how to stream a 3D printer? Well, instead of trying to get the video from the 3D printer closet, I decided let's just put a printer out here, so why not this one? So hopefully we'll be able to see that going. And the next thing we're going to do is set up some sort of ventilation system. So hopefully we'll do that on a stream, maybe even Friday. We'll set up some kind of ventilation system so we can do like resin prints, and we can laser cut, and all that good stuff. So yeah, that's new. Come on, focus please. So this is the board for the project, and it's really simple. It's my very favorite processor. Everyone loves the Teensy. It's my very favorite processor, the Teensy, and a Polalu micro stepping driver. And the other stuff is real simple. It just has a capacitor and a USB-C port and some terminals to plug everything in. It's really simple. Like the Teensy just waits for a random period of time. It uses the stepper driver to turn to spin the piece of art very slowly for a while. Because it's a micro stepping driver, we can spin it up very, very slowly, and at too high a basically we can spin up slowly and at high frequency so that the noise is outside the human hearing range. We can hopefully run it at 20,000 kilohertz. Basically it worked all right. The code, basically the schematic, as it were, is fine. The code still needs some work. So for the prototype, so I decided for the real deal to basically keep the same schematic as the prototype, like build it out of modules instead of doing it from components. This is a calculated decision. I know a lot of people's, like a lot of folks have this hang up where they feel like they have to do real engineering. But you have to balance the time versus the benefits. Like, yes, I know I'm capable of taking these and improving them and implementing it from components on a circuit board. But how long will it take to place all those components, right? Like, how long will it take to lay out that circuit board? Is it really going to improve the project? Probably not. Like, I feel like if I were to, like, instead of, like, buying a module from Polalu and buying a Teensy and putting them on a circuit board, if I were to implement those things myself, it would probably save about $20 per unit. So, because she wants me to make 20 of these things, it would save a total of $400. But in return, it would probably take the amount of time it takes to engineer the thing from 1 day to maybe 3, and the amount of time it takes to assemble each one from about 20 minutes to maybe about 10-20 minutes to like maybe an hour, maybe more, depending on if it needs a stencil, if they're leadless components. Plus, it increases the chances I do something wrong. Yes, using modules using modules not only decreases the chances that I do something wrong, but when I do something wrong, it's more likely it's going to be like a shorted trace or a missing wire or something like that. So it makes the problems easier to solve too. So I decided to take a calculated decision and basically all I'm doing is really all the circuit board is really a carrier board for these modules. And I'll show you that in a sec. Let's switch back over to the overhead view. Let's get our mic out of here. So this is sort of what the prototype. So this is the prototype here. Basically this is our prototype. Ignore the wires. I remember I stripped everything out so I could reverse engineer my circuit here. So yeah, we've got the piece of art mounts here to the spindle. This is what turns it, and you'll notice it's got this pocket here. I don't know why every time I open OBS it resets the every time I open OBS it resets the parameters for the video. So it keeps auto-focusing, and I have to go back and change that every time. If anyone has a lot of experience with Logitech, or maybe this is a webcam in general thing, basically, if you know how to make it remember its parameters, then please let me know. So this thing, I actually want it to turn 180 degrees. There we go. Now it matches what I'm seeing. Yes, I wear my ring on my left hand, as is tradition. I don't want people to realize that I'm some sort of sinister lefty. All right, so this is the thing. You'll notice it's got a little pocket right there, and that's because it holds. Wait for it. Where did I put it? Oh, I think I was actually using the thing. Where did I put it? Here it is. It was buried under a bag of trail mix. Holds a USB battery. But yeah, this seems like jank. And when I first came up with the idea, it took me a while to settle on it. Like, I came up with this idea fast, but it took me a while to, like, actually go through with it. Because I'm like, this is pure jank. Like, this is the stupidest idea. But it turns out that this is actually a pretty good solution. So, the idea is that by powering it off a USB battery, right? By powering it off a USB battery, we don't have to make like a docking station for a lithium pack, right? Instead, like, the person can just remove the piece of art from the device, unplug and pull out the USB battery pack, and charge it, right? Like, and then when they're done, they just throw it back in, hook it back up, add it back, and there you go. It seems, yeah, but it sounds really janky. It took a while. But it turned out to actually be a really good solution. On top of all of this, bare lithium batteries are, like, batteries in general have to be shipped ground. Like, you can't get batteries quickly. Like, even consumer batteries like this, because they're a fire risk. They have to be shipped ground. So, I feel it seems like I've missed a couple of things. I'll get right back to you. But yeah, so got the battery, and bare lithium batteries are even harder to get a hold of. So there's a chance that it could cause significant delays, especially because we're not going to use just one cell per. If I were to make a battery pack for this, it'd probably need, like, if I were making my own battery pack, it'd probably need at least 12,000, 15,000 milliamp hours, and that's a lot of batteries, right? That basically means I need to order 6 batteries per each 20, give or take. That's 120 batteries, so that would be a couple of flats from the manufacturer. So this is actually a good way to get a hold of these things in a hurry. So yeah, this is a special USB battery pack, by the way. This is also. J3 makes an excellent point. It's a good idea if the person who's charging it isn't technical. Yeah, it basically makes it super easy to use, and that's what we want. So remember, like, us engineering types are it's always, what's the way of saying this? It's always tempting to solve things in the clever way, or the way that takes work, right? But it's not always the smartest way. Sometimes it's not always the correct choice. Sometimes the dumb decision is the smart decision. Yeah, no, that's my what are they called? My aphorisms are terrible. Anyways, this is a special USB battery. It's made by a company called Voltaic, and I think it's around 20,000. I think it's around 15,000 milliamp hours. Yeah, this is a special battery because you know how most USB battery packs, anyone who's used a USB battery pack to make if you've used a USB battery pack to make a lot of electronics projects, and you optimize the projects at all, you'll know that a USB battery pack turns off if you're not drawing a certain amount of current. And this, yeah, normally this is good because it keeps the battery from draining itself dry if you forget to, switch it off. But this is bad because that limit is usually higher than a microcontroller will consume on its own. Sometimes. But if you're trying to use power save modes, right, if you're trying to reduce current consumption by putting the thing into sleep mode, it's definitely going to be drawing too little current. So if you put this thing into sleep mode, the battery will switch off, and you can't turn it back on. There's no way for the microcontroller to draw current to turn the battery back on. Like, you can't even push the button, because there's nothing to push the button, it's asleep. So this battery pack lets you switch it on. Let's see, I think if you hold the button, you might be able to see the little LED there. It starts blinking. Yeah, I think that's how it works. So yeah, this battery pack, you can lock it so it never goes to sleep. So that's what we were going to use. Problem is, I don't think the company that made this thing is doing too hot. So I couldn't buy enough of these to fulfill this order. So I had to get regular ones. I had to get regular battery packs that don't have this feature that are going to turn off. So here's what we're going to try to do. Here's the plan. We're going to hook this up to a regular USB battery pack, right? And we're going to run basically, like, we're going to put this thing to sleep. We're going to figure out how long the battery will stay awake, right? We'll see how long it waits to see if the current comes back. We'll put this thing to sleep for 1 second less. Then we'll take it out of sleep. We'll run the motor for just long enough, a millisecond, just long enough that it resets the timer in the battery pack, and then we'll go back to sleep. And hopefully that'll let it work. I did get bigger batteries, so we're going to see how much current the thing draws when it's... so that's another thing to check out, to see if it needs to see if the current consumption will still be too much. Yeah, so that's what we're doing today. We got a couple super chats. Thank you very much, Brooke, for keeping an eye on that for me. JD Man, thank you very much for the super chat. Hey, I love your channel. I'm an EE student and would love to get into prototyping. Any tips on how to get started? Depends what you're saying. I mean, depends on like, you know, what you're interested in doing. If it's just for fun, I mean, if it's just for fun, then, you know, your focus is on building stuff. If it's for work, your focus should be on finding clients. Don't worry about if you're good enough. Worry about finding clients. I started taking clients before I was very good, and, you know, like the whole, you know, imposter syndrome and all that. And let's be honest, like, I didn't know what I was doing, but oftentimes, like, you know, clients don't need as intense engineering as you think. Often, you know, a lot of prototypes, most even, can be fulfilled using just off-the-shelf stuff combined in an interesting way. And they're not necessarily hiring you for your for your incredible technical expertise. Sometimes, like, they just need to get their chips on the board. So if you're interested in doing it for work, just look for clients and then learn on the fly. Whatever it is, if you're interested in doing prototyping, you need to get comfortable doing two things. The first is going wide. It's a lot of people who, engineers, especially people who've gone, in my opinion, who've gone through engineering school, have, like, when you're around professional engineers, you develop this mentality where your worth, basically your ability to be respected, is determined by how deeply you know your topic. Like, if you got two engineers and one of the, you know, I feel like if you got two engineers and one of them is like, oh yeah, I did, like, you know, I did a little thing with the robot, and I did this thing with like, you know, I did some stuff with some radar, and I did some stuff, like, I did this little radar project, and I did a little, you know, I modded a Nerf blaster. Another person says, like, oh, I do gigahertz radio for you know, for the government or something. Like, yeah, oh yeah, like I do. Oh yeah, like you do matched impedance traces. Yeah, mine have to be accurate down to like 0.01, down to like 1 sievert. You know, the first person to be like, oh, I'm not worthy. That's not what you want for prototyping. For prototyping, you want as much experience, as many things as possible. So it's not so much like, you know, you don't need to, like, what's the way to say, you know, you don't have to have comprehensive, you don't want to have comprehensive knowledge about any one thing. It doesn't, like, if you are the expert at motors, you know everything there is to know about, like, every kind of stepper motor and every kind of servo and all that, you are going to be restricting yourself too much because you're going to get a client and they're like, oh yeah, I need something I need something with a touch screen, or I need a touchless interface, or have you ever integrated something into a car's dashboard? So yeah, you want to build an experience with as many things as possible. And if you're doing this just for fun, work on your own projects. If you're doing this for fun, focus on your own projects. Don't work on the same project for too long, right? Try to finish, this second point. You got to be fast. It's really easy. Like, I say this a lot in a lot of my videos, and this is why. You have to be fast. If you're a professional prototyper, the deadlines you will be working under are far faster than you would at a regular engineering company. You will regularly have to finish projects within a week of receiving them. Even larger projects, right? Like, you might have projects that keep you occupied for years, but you have to show consistent progress. And I don't mean like showing the number of lines of code you wrote. No, you're in the hardware business, so you have to show hardware moving forward week after week. And that might mean structuring your work a little differently so you sandbag work so that, for instance, you might have laid out the entire circuit board in 3 days, but you have a lot of code to write after that, and the client's going to think you're doing nothing. So finish the circuit board, but show a little bit of the board on Monday, work for the next 3 days, show a little bit of the board on Thursday, work for the next few days, and so on and so forth. So you have to know how to you have to get experience structuring a project and working quickly. It's nothing like the constraints I work under now for YouTube, where every project has to be done in a week. But you do need to be able to start very quickly and work predictably. That's not something you can really practice. Something that comes with experience. But over time, you got to focus on developing your estimates and forecasting problems. Because at the end of the day, when you tell someone when someone says, I need this thing, when someone tells someone tells you, oh yeah, we have an investor meeting in 3 weeks, and our engineers are working a little too slow. We need you to make it look like our product is done. Basically, we need to look like our product is functional. We have to have something to show the investors in 3 weeks. They don't care if the part you were using goes out of stock. They don't care if you ran into an unexpected problem and it doesn't work. They don't care if you accidentally put a short on the circuit board and you have to spin a new set. They don't care. That investor meeting isn't going anywhere. You have to finish on time, and it's hard. Yeah. Let's see. Akelia, our longtime supporter of Patreon. Thank you so much. Zack, thank you so much for the very generous super chat. Zack, restreaming prints. Did you know Octoprint now has experimental support for an MP4 HLS stream? That would be nicer on your bandwidth than MJPEG with only a 6-second delay. I didn't know they had it built. I didn't know they had it built in. I tried using MP4. I tried sending MP4 over the network, but it tended to get a lot. It tended to be very artifacty and very glitchy. I think it's because of. Yeah, I don't know why that is. I am suspecting it's dropping frames, and I don't know whether that's because of my network rules to limit how much bandwidth can be used by things that aren't streams. And I don't know how much of that is something internal to it. I haven't had a lot of time to experiment with it, but I got to give that. I'll take a look at that. I haven't actually been paying close attention to Octoprint lately. I've been using the E3D tool changer, and that has. Duet web control built in, different system. But I'll check that out. Thank you a lot for the super chat. I really appreciate it. This episode isn't sponsored, so I'm doing this project for pay, but they're not. She's not sponsoring the episode. It's just the project. She gets the publicity for free. Let's see. JD Man, thank you very much for another super chat. Real engineers use off-the-shelf parts instead of reinventing the wheel every time. I'm really into RF, ham, and wireless, but I love all electronics. Yeah, a lot of folks don't want to admit it, but sometimes using off-the-shelf part makes more sense. You can't, it's a way of saying it. There's an aspect of engineering culture where your respect has to do with, basically, your respect has to do with how advanced your work is and how difficult it is for other people to do it. and how well it adheres to like common sense. Like we're supposed to be rational, and we're always supposed to be diligent, and we're never supposed to take the easy way out. But you always have to weigh up, is this like, what resources does this decision take? What am I getting out of it? And does the math line up? You always have to remember that there's a client. You're not doing the engine. You're not. If you're doing this professionally, you are not making this project for yourself. You don't get to decide things about the project. Everything comes down to what makes most sense for the client. Oh, we got another couple super chats. Raghav, thank you so much for the British pounds. Are live streams available somewhere? Love your vids. So for now, they're available. For now, live streams are available for patrons. I recently pulled they're available for patrons. I actually need to put up the last one. I sent out a Patreon poll asking our patrons like if they would be okay with us sharing the streams with everybody. And a lot of people were in favor of it. I still need to figure out exactly if we're going to do that and how we do it. For now, they're patron only. Got to decide if we're going to keep doing that. I think at the very least we're going to start leaving them up. Possibly not this one. I haven't had a lot of time to think about it. I've had a lot of stuff to do. But I'd like to at least leave them up for a day or two so that people in different time zones and people with different life circumstances can watch the replay. But still, nothing beats tuning in live. Lewisser, thank you so much for the euro. Chose that battery for some stuff at work. Careful with more than 1.5 amps. Had them crashing and pressed the button after assembly, even though they're like 2 amps. Thanks for the heads up. Inductive load. These batteries aren't really designed for inductive loads, and it is possible. We have to be very careful with this to ramp it up very, very slowly. Luckily, I don't think I've had the battery crash, but we're also not spinning this very quickly, as you'll see. Like, I think the fastest speed this thing has to go is like 5 RPM, so like one rotation every 10-15 seconds. So these aren't really moving very quickly, and I think it's been working all right. But yeah, also most steppers, like, people aren't really running steppers at 5 volts. Usually they're running them at 12 volts because they're using a 3S, generally a 3S LiPo somewhere in the neighborhood. So we actually have used. We have to be more careful about the current because it's going to draw more current to get the same power out of a lower voltage. So it is relevant. We're going to keep an eye on that. Make sure nothing's crashing or getting weird. Thank you so much for the super chats. I really appreciate it. Let's switch back over here and let's get rolling. Cohen Carnell asks. We got a couple here. Cohen Carnell asks, it seems like your philosophy has a lot to do with making decisions as fast as possible. You ever had to work under constraints that made that impossible, like medical equipment? Well, so making decisions is not something you can rush. Thinking something through thoroughly takes a fixed amount of time. And what you have to do is you have to make it fast. Like, you have to think, okay, I can order these parts, like, I can have these parts here in 2 weeks. Can I have these parts here in 2 days? I can get this board with a 5-day turnaround and 3-day shipping. Can I afford to have this done with a 1-day turnaround and a 1-day shipping? It's going to take me 3 days to lay out this board. Can I can I switch components to lay this out in 1 day? But actually deciding on things like parameters, looking for bugs, all that stuff, it just takes a certain amount of time. You just, I don't know, at least from, like, I rely on my intuition, so I have to look at something, I have to look at something, my subconscious comes up with some ideas, then I have to wait, come back, and do it again. So I generally structure projects that, I try to structure the project in a way that lets me do that. As for, like, projects, there's certain projects that you can't really prototype very well, and biomed is one of them. So if you're doing something like a medical product, you're not going to hire someone like me to go to clinical trials or something. But as for proving a concept, it's no different. Like, it's building something. It's no different than a toy project, right? The whole idea is I get a set of specs, I implement them. I spot some problems, maybe I fix them, maybe I just tell them about them.
the responsibility is on the client's hands. Like, it's impossible for me to verify, like, I can't second guess everything the clients say. Like, granted, if something is blatantly dangerous, I will probably not take that project. Yeah, it comes down to which projects you take to. No matter if you're a freelancer, you're a consultant, you're not going to take every client that presents themselves. You have to turn down some clients. In part, some of the projects are going to be not worth building. Some of the clients are unlikely to pay you or pay you well enough. And on top of that, like, in order to negotiate high rates, in order to negotiate, not high, but like in order to negotiate good rates, you have to present people offers that they'll refuse. And, most of the time they'll refuse the offer, but then they'll present a counter offer and you can meet in the middle. But every once in a while you'll present an offer and they're like, well, that's far beyond what we expected. We're gonna have someone on Fiverr do it. And you gotta be okay with that. You can't, if you're presenting rates to people, if you're presenting rates to people for anything, from sponsorship to looking for a job, doing consulting. Basically, if you're presenting offers and the offers are getting accepted every time, your offers are too low. You should be getting rejected the first time, every time. Your first offer should be rejected. It's the second one that they should take, because you should be close, but not all the way. So I think we'll get going. I think I'll take one more. Enigma asks, what happened to the weekly videos? I understand it's a lot of work, but I really miss them. Can't happen. It's just too... We just don't have... We just don't have the ability to do it. We tried the weekly... Yeah, it's just not possible. I'm just not fast enough. Especially when projects are involved. The weekly videos, like, the quality was getting worse and worse. Quality was getting worse, and the projects were getting worse too. The first few videos, like, we could do weekly videos and projects because we actually did. We did the episode. We recorded the episodes, and built the projects 6 weeks before the episode came out, but we ran out. We were moving too slow. So no, it can't happen. Hopefully, if we can keep, hopefully if the channel keeps growing, like. One of the possible strategies for the channel is that we keep it growing and eventually be able to rent a studio, hire a team, and like that's how folks like Mark Rober, the Hacksmith, like that's how even to an extent. Yeah, I was gonna say Michael Reeves, but it's not totally accurate. That's how those channels manage to make weekly videos, is that they have an entire team. I think the Hacksmith has like 12 engineers and 3 producers, and like 3 people working on the films. Cohen Carnell says, I didn't notice a dip in quality. I did, with the numbers. Our numbers were going way down. We had this like 5-week streak where none of our videos broke 100,000 views, and it sucked. So yeah, so here's what this thing here's what's going on here. We've got the stepper mounted here. In the back, we've got a little compartment here for the board, and we've got a compartment here for the battery, and there was like a USB cable that snaked in here. So this thing is way overspecified. It's way too big. Like, I seriously. So there are a couple reasons. The first is I seriously overestimated. The first thing is, I thought initially this wasn't going to be going in a gallery. I thought this was going to be sold to individuals and going to their homes. And the reason this matters is because if this is going to people's houses, we have to worry about kids. In particular, we have to worry about kids like grabbing onto the disc and putting their whole weight on it and just ripping it off the wall and getting a plastic disc, slicing off their toe or something. So this thing, I tried to spec it out to support the weight of this 1 meter by 5 millimeter disc, as well as a 50 kilo child. So this thing is 5 millimeters thick. It's like 2 millimeter walls, like 30% infill. Took over a day to print. It's nuts. So we don't need that. This is going to be installed in a gallery. So it basically just needs to support its weight, as well as I think support its own weight and probably an extra 10 kilos or so of torque is going to be put in it as the disc is being replaced. So yeah, it's also too big. It's the way I laid this out is really stupid, and you can see that. See, this is the motor is recessed into the the frame, and that creates more torque, and basically requires us to put more. Basically requires us to make the all the mounting stuff stronger. So this needs a lot of revision. It also takes too long to print, so yeah, we're going to revise it as such. The motor, the stepper motor is basically the same. I end up changing it because this one is too... yeah, I end up changing it because this is too... no, not 50 kilos for a kid. I'm at 25 kilos, around 50 pounds. Yeah, Epe is right. Yeah, so... Yeah, anyways, yeah, the piece we're making is... so basically this is a mount for a transparent piece of art. Oh, I missed a super chat. JD Man, thanks a lot for another super chat. Thank you for the advice. I'll start working on clients. Where's a good place to advertise? Unfortunately, you're screwed because it's a pandemic. Best way I ever found to market myself was at meetups. Once the pandemic ends, move to a city with a large demand for electrical engineers in this case. New York City, Denver, San Francisco, a place with a large startup scene. One way to help research this is go on something like freelance.com or something and just see where the jobs are. Yeah, so move there, go to every relevant meetup. I don't mean some of them. I mean every single one. Go to all of them and bring projects. Get every speaking gig you can, go to every conference, go to every meetup, go to every one of them, be as loud as possible, attract tons of attention, and you'll find clients. Clients also will recommend you to other people. But right now you can't do that because there are no trade shows and there are no meetups, and on top of that it's a recession, so people aren't developing products, so unfortunately we're dumb. So basically we're building this mount for a piece of art, and so let's see. So yeah, we've got this set. So we've got to so we can go and take a look at the circuit board. But that's what we got here. So yeah, today's agenda is we'll try to get some circuit boards in the mail. Then we're going to test out the motor we're going to test out the. We're going to be using this guy. We're going to test our new motors, just make sure they can do the job, and we're going to test our new USB batteries to try to get try to get that going. Like try to keep the battery from going to sleep without drawing too much power, and also make sure it's not going to, it's not going to draw too much power and shut down. Generally, these things have polyfuses in them, so if you draw too much current from them, they'll temporarily lock themselves out. Then we're going to replace this 3D model. Hopefully we have a chance to set one up, and if we run out of things to do, then we have some interesting stuff to show off. Raghav, thank you so much for another super chat. Have a lovely day. You have a lovely day as well. BricksPixel points out the hardware startup scene is way less hopping than it used to be. That is true. But hardware startups were only... hardware startups were only a portion of my clients. A lot of wealthy individuals had passion projects needed help with. A lot of artists needed like kind of one-off work. Oftentimes, like get contacted by like a museum or like a museum or a something or other. Basically, they had commissioned a one-of-a-kind piece in the past, and now it needs maintenance, and the original person can't help them. So they need someone else to come in. You've got companies that just intrinsically make small numbers of products, like HVAC companies, industrial equipment, industrial automation, like all kinds of stuff like that. So let's head over here and let's take a look at the circuit board. Let's take a look at the board. I already did a lot of the work for this, but I still don't know if it's at 100%. One of my policies is JD Man says, I live near Seattle. Thanks a lot for the super chat. I don't know that much about it. I know that Washington, I don't know. I know that Washington has a lot of enterprise software. Because you have Microsoft and others, Microsoft HP, I think, feed into that. So I don't know. There might be hardware as well. So it could be neat. So let's open up our. I think I called this the Fusion Mandala. Yep, that's her name for the project, the Fusion Mandala. Let's open up our board. Actually, yeah, I can show you here. Hardware startups. Veldorg says it's more some scams give the space a bad name. Hardware startups, I don't know. I think they have as many. There are as many sketchy hardware startups as there are sketchy software startups. I do think they're more amusing. I'll definitely give you that. Yeah, I have an interesting fun fact about Theranos that I'll talk about later. But yeah, at least for now. So yeah, this is the board. Let's run a rat's nest to fill in the planes. So yeah, this is a more compressed version of this. They're basically the same. So yeah, we've got. Let's just make sure that everything is in place here. View motors, ground. All right. So we've got our Teensy right here. We've got our Pulalu driver board right here. We've got USB-C here. We got USB Type-C here. We're using USB Type-C for a reason. I'll show you in a sec. We have a little capacitor just in case. And we've got a set of spring terminals here that the stepper is going to be attached to. And this is a much smaller and more compact board. The reason... All right, so... Yeah. This is a really simple... it's just a really simple schematic. Yeah, simple schematic. We just have... these, so yeah, real simple. We've got our we've got our USB Type-C. USB Type-C is supposed to be implemented symmetrically. So for each pin on it, there are actually two on diagonally opposite angles connected. So that's why we have like C1, C2, that's why USB there are 4 pins, ground there are 4 pins. CC1 and CC2 are current control. Their role is for the peripheral to tell the to tell the power supply how much current it needs. So these 5.1K resistors should tell the battery pack that this thing is going to try to draw. I think it's going to try to draw 2 amps if I set this up right. I think it might be 1 amp. I think it's somewhere of the neighborhood. Yeah, I calculated it already. So yeah, I didn't go through the trouble of making a schematics and circuit board symbol for the Pulalu driver. We're just using 2 headers. And here we have the Teensy. This is a pre-made footprint and symbol for it. So yeah, it says Teensy 3.0. We're going to use Teensy 3.2 because I have a tremendous number of them left over from a past client, and I just realized that my projects, the projects I build for the channel tend to use just a lot of different microcontrollers. So it's unlikely I'm going to use all those Teensys. We're going to use them for this project. So yeah, this wasn't a very difficult circuit to design. The hardest part was probably making a symbol. So this symbol here is untested. This is a symbol for the USB Type-C port. I am using. I saw a few people asking what I'm using. This is Eagle. We're using EagleCAD. That's the software we're using. So check this out. Let me open up. So here we're gonna open up the milling layer. Here we go. So I've never actually done this before. This has milled slots. These pins, these pads here that keep the thingy on the board, or slots, like the little tabs. So these have to be milled out slots, and I've never ordered milled slots from OSH Park. I don't know how to pronounce it. I think it's OSH Park. I've never ordered those before, so I followed their instructions, and hopefully that works. So yeah, we've got this thing designed, but it still needs a bit of work. The first thing is, Eagle has this really weird
like way it zooms in. So I know I'm having a lot of weird, you know, jiggling it all over the place. Yeah. Sequoia asks, why do you need a microcontroller? I suppose it would be possible to implement this with like timers or something, but why do that? Like, why do all that engineering? Like, why bother? I already have the microcontrollers. So, like, yeah, why bother? It's not worth it. It might even draw more power, because with this we can alternate between a low power sleep mode and stepping the thing, and we also have the ability to vary how fast we step it, but mostly it's easier to program a microcontroller than it is to design a circuit board. Yeah. Yeah, this is the old Eagle. I don't want to use the Autodesk Eagle. I don't want to pay a monthly fee for software. I feel like I've ranted about that enough. Okay, so so here's the first thing to do here. We're going to find out how badly I screwed up. Let's actually turn this down a little. Alright, we're going to find out how bad I screwed up. We're going to run design rule check. We have the Osh Park design rules. It's actually really, the text is very small. We have the Osh Park design rules. Actually, let's work on the, I'm going to open up my settings here. Come on. I'm actually going to drop the, I'm going to increase the, I'm going to drop the display density here because it's really hard to see anything. Omega Rogue LPS, what about the Eagle integrated into Fusion? There is Eagle integrated into Fusion. I don't trust it. I don't want my circuit board files to be saved in a format that I can't open in a piece of software that I own. So let's increase. Hang on a second. Display. Yeah, there we go. So let's jump this up to 200% resolution. Is everything going wrong? Everything's going wrong. I don't think Eagle likes this very much. Let's. Oh yeah, I think I ruined. I might have kind of ruined everything here. Let's. What do you say we close Eagle and reopen? What's this black box? What's the point of that? Why is there a black box here? Why is there a black box? Nova Plays Games and Connor Barnes, thanks a lot for the super chats. I really appreciate it. I see some folks trying to use bot commands. We haven't set any bots up yet. I'm not impressed with any of the YouTube bots. Yeah. On top of that, like I don't like bots because like people forget what the commands are and everything. I don't know. I don't have time to set up all this crap. Like our time is just too limited. Like. You know, I work I'm generally working until 3 o'clock every morning, just to keep the channel going, and just to keep the channel going, and I don't have time for all. I don't have time to set the stuff up. I don't know why. I don't know what the hell is. What is this box? What's the point? Yeah, I don't know where people get all the time for this stuff. I'm just not a. That's the other reason why I take trying to be fast so seriously, because by my nature I'm not very quick. So I guess this only happened at 200% resolution. That's really weird. Yeah, so that's why all my focus always has to be on go faster, go faster, go faster, because I just have a hard time actually. Checking all the boxes by the time the deadline shows up. All right, so let's try this again. I seem to have crashed auto hotkey. I barely have time to maintain the stuff I already have. All right, let's open up Fusion Mandala. Here we go. Yeah, this isn't helping at all. I think that they programmed everything into Eagle in a fixed resolution, so a fixed density. So we don't actually, at the end of all of that, we don't gain anything by. Sorry, you're not going to be able to see anything. Life sucks. Wear a hat. I guess I could drop the resolution, but that's a bad idea. Yeah. So.
let's run a DRC. So we're going to run Oshpark's two-layer DLC. This is a design rule check that basically spots if I've made any mistakes, like had traces that cross each other, make traces so close together that Oshpark doesn't think they can manufacture it. Let's see what we did wrong. No errors. I'm suspicious. Yeah, this is suspicious. Let's go back and just double check our schematic. So, all right. So let's just we'll go through each pin one by one. So reset and program we don't care about because we have access to the reset button. We're not using ViewBack because we don't care about the time. We're not using analog ref or analog ground because there's no input to this. It's just output. So Vin is going to feed 5 volts from our power supply. 3 volts out. Yeah, that's going to power the 3 volts out. That's going to power the thingy, the motor driver. Let's just double check that this is actually the way it's supposed to go. Yeah, got ground here and here. We got the 4 stepper lines. Those are connected here. I'm going to use show. I'm going to use the show command. Actually, let's move this all closer together so we can zoom in further. I guess I could just connect these together, but I want the labels there for reference. So let's just make sure everything's connected, right? Sometimes you can end up with a label that is not actually on the wire it's supposed to be, but I think this is fine. Enable motor 1, 2, 3, step and drive. Let's just verify that we're using the PWM pins. So let's open this up and let's go to TNC pin out. I know I have one on my wall, but I can't show you that one. So let's see. Here are our TNCs. What? Is this a TNC? Oh, it's like a little SD card module? That's pretty neat. Ah, isn't that cute? Is that what this is? Oh, you just cut the board up in pieces. There's so many. The TNC 4.1 has so many pins it needs 5 diagrams to show you all of them. I love PJRC is a king. He's a gentleman and a scholar. So let's move all of these over here and let's just verify that the right things actually are PWM. So PWM pins are pink ones. So we have the enable pin that doesn't need to be PWM. Motor 1 and 2, right? What do these do? The step M1. Oh right, M1 and M2 set parameters. I think step. It needs to be PWM. That is PWM. That's pin 6. 1 and 2 need to be PWM, and they are. That's it. Okay, so this is hooked up correctly. Over here we've got. We don't need data. We don't need data coming in because there's no reason for. We don't need to run any data lines. We're not going to because those aren't broken out easily. If those aren't broken out, we'd have to add pogo pins to the board, and that would add extra time, cost, and complexity. Yeah, so I don't think I made a mistake. I think the board is just... I guess the board is just that simple. Are these labeled correctly? Let's see. Blue, red, green, black. Blue, red, green, black. I'm actually going to move this so... I'm going to move these labels so they line up a little better. Yeah, so our wires aren't going to... We're still going to be able to access the screws. Oh, I seem to have missed a super chat. Rudy Niemeyer, thank you so much for the extremely generous donation. Thank you so much. It's very generous. As a fellow hybrid engineer educator, I love the detail with which you explain the ropes to the current next-gen home prototyping makers. I try. I mean, at the end of the day, my goal with this channel is to get people to build more projects. And I'm trying to work on the education end of it. It's not something I have a lot of experience with, but it's definitely something I need to work on for the channel because people want some tutorial videos, and I want to make them. I got to make them so interesting that even people who are actively hostile towards a topic will want to watch them. You know, I'm still working on it. Is this capacitor of the wrong polarity? Is this capacitor of the wrong polarity? Is the anodes
the anode of the capacitor is supposed to go to ground? I don't think so. I think it's supposed to go on VCC. I think this is correct. Yeah. Some folks were asking if I tried KiCad. I have. So Eagle, I don't want to use Eagle. I just want to make that clear. I'm really sick of it. It's downsides, in my opinion, especially now that Autodesk bought it and has their ridiculously hostile business model. I don't really want to use it. So when I reached this conclusion, I played around with OrCAD, KiCad, and Altium, and of them I settled on Altium. Altium's great. Problem is, most hobby projects are done in either KiCad or Eagle. It's like very few hobbyists even have access to Altium. And since I want people to, use my projects, I can't use it. So I decided to settle with what I already knew instead of learning KiCad. Yeah, there are only a certain number of hours in a day. I don't have time to learn anything new anymore. So yeah, unfortunately we're sticking with Eagle for now. Womp womp. Although Altium is trying to do more outreach to makers, trying to make the product a little more maker friendly. So maybe at some point there will be a good free version of Altium, and yeah, some good free version of Altium, and I'll be able to start using Altium for projects. I really like it. I think it's super high productivity. Anyways, let's take a look at our DRC. Let's just see if there's anything that needs to be changed. 2 layers. Alright. I'm gonna change, basically, let's see. I'm changing everything from 6mm to 12mm. Let's cancel it. I'm changing everything from 6mm to 12mm because there's really no reason, change it to 10. There's no reason for everything to be so close together if we don't have to. Like, it's set at 6, basically the closest detail Oshpark wants you to make is 6 thousandths of an inch near each other. Let's see. So we have a. All right. So let's see. So these are close together, but I think that's it. Yeah. There's nothing we can do about that except for switch parts. I don't think it's likely. If Oshpark thinks they can do it, I trust them. So yeah, between copper and the dimension. Between drill and hole. So these stats these numbers right here are how far apart things have to be from areas that get cut. So like how close copper can be to the edge of the board, how close they can drills, how close holes can be spaced together. I think that's fine. Minimum width, let's call that 10. Minimum drill, yada yada. So these are the smallest things that they can manufacture. Restring are how much metal should be around pads and holes. So I think that's all right. Missing some clearance. Yeah, the clearance is fine. That's just this right here. I think this should be. I've used this footprint before, but a little extra copper never hurts. So let's. So here, check this out. So you see how thin the copper is. This green area. You see how thin this area is around the holes. Yeah, I think that might make it a little tricky to solder to these, and since we have the room, this isn't a very dense board, so I'm going to use restring and try to make this bigger. So let's see. So I'm going to hit apply. Check this out. Did it work? Did it do anything? No? Alright. So let's actually go to 12. Check that out. See what just happened? I now made every pad larger, so that'll make them easier to solder to. So let's see. We're not at risk. Yeah, like we don't really have. We're not trying to snake. We're not trying to snake any traces in between pads. So we can actually like really open this up. This will make it much easier to. This will make it much easier to solder the pins. Because it'll give us more area Oh, we need to add a little more room around him. Basically, this will allow us to solder this board faster and more reliably, because it will it'll give the soldering iron more room to touch, more surface area. So you see what happens. It's so we've made the pad bigger, but it hasn't made it hasn't increased the area between the copper between the copper pore and the whatchamacallits, the copper pore for the ground layer and for the pads. So let's do that manually. Where does that go? SMDs, that's not what we want. Thermal isolation. Let's add a little more. Let's add some thermals here. Yeah, so this is basically like for ground pins. So you see this ground pin right here, the way it looks like a cross? That's because there is thermal... Wait a second, my mouse is invisible. Why did that happen? Why is my mouse invisible? There we go. I want people to be able to actually see what I'm doing. So, yeah. Anyways, yeah, so the purpose of these is... So there's some thermal relief, so that when I'm trying to solder the ground pin, the ground plane doesn't just suck all that heat up and make it impossible. So yeah, we'll increase that a little bit, make it a little easier to solder. So here's our masks. So let's see. The stop mask is let's see. Yeah, so the stop mask is how much area it doesn't have solder mask on it. Basically, if the solder mask tends to overlap pads, we can add a little more relief, open up a little more room, and have a higher chance of being able to solder. Cream, stupid name. The cream is how much solder paste to put on every surface mount pad. We're not using stencils, so it doesn't matter. So we can also have it check. We'll have it check angle. I like that as well. Check angle means that it's going to have, let's see, the angle makes sure that every wire is at 45 degrees. It's not necessary for, basically it's not necessary for development. It's not an engineering thing. It's a professionalism thing. So let's see. So we want between different signals, wire and pad. Let's see, clearance. Oh, alright, no, I think we're fine. So here, we just need to rerun the rat's nest. There we go, rerun rat's nest to recalculate the ground, pore. Okay, very nice. Let's just open up our DRC one more time, and I'm just going to change we're going to reset our clearances. There we go. Why? That should be fine. That's stupid. Get that crap out of here. All right. So yeah. Wait, what happened here? Is this let's see. Is this enough room between these? I think it should be enough relief. Okay. So here's what next step to do. Let's see. We're gonna pick our smallest drill. Wait. Nope. We're gonna. Diameter is regular. We're going to pick the smallest drill, 0.5 millimeter, and we need to add some ground vias. So we need to add some stitching vias. Basically, right now, the top and bottom there's a ground plane on the top, ground plane on the bottom, and they're only connected with they're only connected by ground pins that go through and solder into both. And let's see. Oh right, it changed the. All right, now these pads are overlapping. Huh, that's interesting. I completely forgot that would be. Oops, I completely forgot that would happen. DRC. All right, so let's reset our restring. Yeah, so let me think here. So what happened here is that it resized these pads, and I know there's some way. I think there's some way to tell the system that it shouldn't change these pads, but I don't remember what it is. So let's see. So yeah, unfortunately, I think this is not going to work. Restring. So minimum is, I think it was 6.
or I think it was it 5? Yeah, because I didn't change the middle. That was 5. There we go. Yeah. So yeah, unfortunately, it's going to be a pain to solder. Oh well. Let's actually let's change this. So let's just do this in the package. We're going to open the package. We're going to yeah, we're going to open the package. We're going to hide everything but the pads, right? We're going to select the pads. We're going to change. Let's see. Change diameter. Let's see if this works. Oops. Change diameter. It's a little better. There we go. All right, we'll save this. Close this. Let's update all of our libraries. There we go. Easy peasy. I just need to make sure, like, if I open up old drawings, I now need to remember that, just in case. Yeah, dependency hell being what it is. Okay, let's get rid of that via. Okay, so here's what we're going to do. We're going to drop a via. I like making our vias octagonal, just to signify that they're not pads. So, yeah, so what we're going to do is we're going to stitch the top and bottom copper together using some vias. So you'll notice that that's not happening here. This via isn't connected to anything, so all we have to do is rename it ground. And now it is a ground via. And then we can just copy that. We can copy that over and over again. So yeah. So I'll copy that to get 2. Move, or copy both of those to make 4. Yep. There we go. Yep. I'm a little rusty with Eagle because I generally don't make circuit boards for the channel because it takes too long to design and then manufacture them. So yeah, yeah. It takes so long to design and manufacture them. We are going to make circuit boards in an upcoming episode, but for now, I haven't done it in a while because it's just too slow for the nature of YouTube content production. I bricked on that one. I think that's close enough. Alright, so let's copy even more of them. We're going to turn them sideways. Don't worry that these are... I don't think we need to worry about putting them everywhere. Don't worry that that they're overlapping text, because that shouldn't matter. We should put a smiley in there. I sometimes put Easter eggs. I'm going to move this one over here just to give that ground pad from the capacitor a little more work. One of the things, or just give it a little more connection to the bottom layer. One of the things that I don't like about Eagle is that for some reason the copy command, you can't just run it over and over again with groups. You have to constantly type copy over and over again. It's really weird. So I'm adding in some more around every ground pin, make sure that they're connected top and bottom. This means that basically the return signal, the return path for ground now is always going to be, let's see, let's put this, let's change our grid. Yeah, the return path for ground is now, I have this in, I'm trying to switch to millimeters here. Return path for ground is always going to be short. In order for a signal to make it back to ground, it doesn't have to snake around. And just slightly improves system stability. Normally this doesn't matter very much for a board this simple, but I'm going to be a little more conscientious with this one because it's an inductive load. It's got a motor. So could matter a little bit more. At the end of the day, though, it doesn't cost anything to add vias. We're not paying by the drill, so there's no reason to be stingy. Let's see, and now let's just add a couple more. Let's just add a couple more vias anywhere we think we're gonna have a little ground plane island. Basically, any place where that one's a little too... Oh, no, want the module. Yeah, any place we think that the ground is going to need to snake around, we'll just throw a few more vias in there. And yeah, this is just part of making a board professional. Definitely want to add more vias around here, because this is where the ground is actually connected to the power supply. So yeah, we definitely want a bunch of ground pins around here. That's a pretty important place. Let's run a rat's nest. Oh, did I not name any of these? I thought it was copying. Did it not copy the names? All right, well that's no problem. We will just hide everything but vias. And yeah, we'll hide everything but vias. We'll group. Hide everything but vias. We're gonna group all. We're gonna name everything in the group at the same time, I think. I think we can name. Name all of them ground. And should work. Why is his name ground 6? What did I mess up here? What did I mess up here? Yeah. Why did that happen? Did I mess something up about naming these? Does this not work anymore? Do we not? Each one gets a different net. Why did this happen? Why did that happen? Which ones need to be named? Why did that misbehave? This is really weird. Let's see. Maybe I'm forgetting something. Let's open up the help page. Let's take a little look. I've now lost all of my viewers because as soon as I struggle with anything for 2 seconds, explaining at the name. As soon as I struggle with something for more than a second, there's nothing in here. All right, that's great. I lose all my viewers. So show ground. All right, we're in business. Let's see. All right. So yeah, like we don't have that many. Worst case scenario, I would just delete all these and do it again. Let's just make sure we didn't miss any. Oh, it'll be really easy. It'll be really easy. That's a different via. Okay, so now we'll just go to last. Let's do a rat's nest. Any of these that have a gap around them are we name them, but it looks like that's not the case. So let's just copy one more here. That's fine. All right, cool. Alrighty. So we want to make sure that. So here's what we want to do. We want to make sure that. See, like this part. See, all right. So check it out right here. We've got this eye, right? The silk screen is covering a via. We want to make sure the silk screen is applied over the via. So we may have. So that's yeah. We want to make sure the silk screen is applied over the via. Silk screen will only be applied over solder mask because silk screen doesn't stick to metal. So we have to make sure the solder mask appears over our vias. And the easy way to check if that's being done. We just want to see the. We just want to see the layer. I think it's stop. It's mask stop. Yeah. All right. So check this out. So you see this white outline, this white shading around this. That means that solder mask isn't going to be applied over it. So we actually, of all things, we solved this problem in DRC. In our design, I don't know why. I don't know why. Here we go. So in our masks, see it says limit, right? So in this case, let's see. This is a 0.5 millimeter drill. So we want to just change the mask limit to 0.5 millimeters. There we go. See that? Now that shading has disappeared. Now we'll draw solder mask over our vias, and now we'll draw silkscreen over the solder mask. So there we go. So let's take a look at our our errors. So we have a couple of we got a couple of angle errors. So we're going to engage the rip up tool, and we'll deal with those. Most common reason this happens is that's weird. Most common way this happens is this commonly happens when you route a trace and then you move the part. It often will not. It often won't move at a right angle. So let's rip this up as well. Let's see. You can. It's easy to tell where these things are because they're shaded. There's a little bit of blue shading. So let's see. We've already got that. We've already got this one, right? I think we got that one. Yep, we got this one. We got this one. Cool. So let's run another rat's nest. We now have to reconnect these, but that's going to be easy because everything's now back in the grid. So let's just do that real quick. Let's see. We want a wider trace. We want 45 degree angles. Very nice. Rat's nest says we have 2 air wires, so we missed 2 of them. Air wires are technically this isn't an air wire. Technically they are connected, but we want our automated tools working for us. Here we go. So that should be it. We should no longer have any air wires. Nothing to do. Excellent. So stop mask. These are things that should be covered but aren't, or vice versa. Let's see. Oh, right. This is where silkscreen overlaps solder mask. It warns us about this, although it doesn't. Remember, because silkscreen can't. All right, so silkscreen can't be applied over solder mask because it doesn't stick. At one point, this was a problem because the circuit board manufacturer would attempt to do it, and then you wouldn't be able to solder to it because their silkscreen or would just flake off. So we don't care about this though because most circuit board manufacturers now just won't do this. They'll automatically filter them out. The reason this is showing up is because the layer is visible. It only shows us errors in layers that are visible. We are hemorrhaging viewers, so I think it's time to end this part of the project, and get the show on the road. So let's run Final Rat's Nest, and let's run a Rat's Nest, and let's export some gerbs. Export some Gerbers. So we're going to use the CAM processor to export files that we can send to Oshpark and make some circuit boards. This is something I don't think I've ever seen anyone actually do in a stream or in a video, so could be interesting. I need my green thunder. Yeah. So this is a piece of software that converts the board file that we've been working on to Gerber files, which are sort of like a black and white image, sort of black and white vector image that the circuit board manufacturer can use to make circuit boards. So let's see. We're going to open. Where did I put it? We want our Oshpark 2-layer with milling paths. There we go. Okay, so each one of these tabs right here, unfortunately I can't make this any bigger, I know. Each one of these tabs is a different type of geometry. So Pardon. Yeah, it's going to produce docks for the solder paste in case you want to stencil, for our copper layers, for our silk screen, for the solder mask, right? That's sort of like a reverse, right? Because it's showing us places solder mask shouldn't be applied. We have our board outline, that's where it has to be cut. This one is also going to have this file here, milling layer, and that is because we have those little slots that we got to mill out. So, yeah, and then we have a drill file that shows which size drills to use and which where to use them. Remember the tool changer, right? Like I thought that was like all kind of hot crap because it can switch between like different tools with different nozzles. And I thought that was cool, but in reality, like, it's nothing special. I've been using that for years and didn't even know it, because if you ever make a circuit board with multiple size drill holes in it, then you are using a tool-changing CNC. Yeah, there you go. Okay, so this looks alright, so let's process the job. We definitely want to save our board and save our schematic. Eagle does not fully support slots. I am aware. Okay, so our job has been processed. Yeah, so let's take a look at it. We're going to go to, let's see here, we're going to go to Dropbox, we're going to go to Projects, we're going to go to Active Projects, Mandala, and here we go. These right here, these files are the ones we care about. So, yeah. Let's see, has Brooke been trying to get my attention? I think someone has. I don't think it's Brooke, though. Not important right now. Let's see. Okay, so we got these. Actually, I'm not even sure this is necessary to process, because I think now we've got a convection oven. If you can figure out why we need a convection oven, then I don't know. Like, I'll applaud if you can figure out why we need a convection oven. But we don't need it for this part. We're going to Osh Park. It's not to reflow boards. Remember, this doesn't have any through hole. This is all through hole. So, oh yeah, like it just lets us, we didn't even need to do the cam in the first place. I keep forgetting that Osh Park lets you just upload Eagle files. They're like the only circuit board fab that I know that does it. Yeah, so we're going to go back to Dropbox, Projects, Active Projects, Mandala, Board File, Upload, and it should process this automatically. Let's see. No, it's processing. Oh boy, isn't this exciting. Oh, here we go. So this is what the board is going to look like. Oh, it looks like we've got a couple... Oh, it looks like we forgot. We've made an amateur move. We made some boo-boos. We forgot to move the label. We forgot to move the part names away from the parts. So you can. So let's see. Otherwise, this looks all right. It got the slots. That's pretty impressive. Slots are milling, and slots are one of those things where you generally like the way it works is. Here's the process. Here's the process. You export your CAD file, right, with your milling layer or whatever, but it doesn't matter. You include an image with your slots circled in red with arrows pointing to it that you draw on saying slots here. And then you send in your job, you call the circuit board manufacturer and you say, hey buddy, my drawing has slots, did they come out properly? And they're like, oh yeah, there are slots here, I didn't even notice that. So then you say, well, I just want to make sure, are those slots milled? Are those slots plated? They say, no, we don't plate our slots. Like, you're going to have to plate those slots. Like, okay, I'll make a note here. So you call back a day later, and you say, hey, can you transfer me to your production department? Yeah, I sent in this file with a bunch of milled slots in it. Can you confirm that there are 4 milled slots here and that they're plated? And they'll be like, I'm like, oh, it seems like they haven't plated them. I have a note here, but it looks like our production guys didn't get the message. I'll send it along. That's how you get slots plated, but it looks like they're doing this properly here. I choked on my green thunder. So, yeah.
Looks like we made a boo-boo. Made a boo-boo. We got a couple of things, actually. The first is our part names are overlapping. The second is that this doesn't have a... The second is that this doesn't have an outline. And the third is we haven't put a single piece of silkscreen on the back, and since we're paying for it already, we might as well add an Easter egg. So let's do that. So first, let's keep these things from overlapping. Let's get smashed. We're going to smash, and smash and smash. The smash command separates the label from the part, so we can move them around independently. And that is what we want. So, yeah. Let's see, we got... Put this here. I like to use CN for connector. And I know some people use J... So you got JP here, right? It's traditionally... Like, it's originally for jumper. But I typically use JP as a to indicate connectors that are for assembly and whatnot, and I use CN to indicate connectors that the user is going to interact with. So like USB goes on connector, but pin headers go on jumper. So let's move these over here. I'm not going to renumber the parts. I don't think that's necessary. Actually, let's, while we're at it, we have lots of room, so let's smash this, and let's move the label from the teensy out from under the part. Just for future reference. It's important, like, I take this documentation stuff seriously. Yeah, I take this documentation stuff seriously, because if you're a prototype developer, it's likely that you are not going to revisit your own projects. It's likely that other people are going to revisit your projects. And if you start developing... Basically, if you know how to use your... if you design the project to be very easy to use, or very easy for people to go back to and look at, if it's documented well, it's labeled well, then whoever the client hires to do their design for manufacturing or whatever can go back and, they'll go back and they'll do a good job. And that makes you look like a better prototyper because you got them to market faster. And believe it, this does pay off. Because someone who makes one product, look, if they don't have in-house engineers, you're making the first version of the product. And likely they're going to make a second version. And it could be that their in-house engineers are supporting their old product. So this is something that matters a lot for prototyping. But let's save before something goes wrong. I think this is all right. We're going to give her the copyright. This is important. Circuit boards are art. It's been proven in court cases that a circuit board is intrinsically copyrighted. So it's very important to put a copyright on it to tell people who the copyright belongs to. Now, this... Okay, information's meant to be free, but what I'm saying here is that you get a copyright whether you like it or not when you make a circuit board, and if the circuit board isn't for you, you gotta explicitly give that to your client, because they might... Yeah, because what could happen is somebody rips one of my things off, I want to sue them, they say, hey, you made a whole bunch of circuit boards, and you allowed other people to make them copyright-free without licensing. That shows that you don't take your copyright seriously. You were being selective and trying to extort this particular person. And that could be used in court. So it's very important to always, whenever you produce copyrighted work, always say who the copyright belongs to, even if you're going to release it into the public domain. So this one's not, by the way. I did this for her. It's her product. She gets the copyright. So yeah, let's throw something on the back. So let's do some text, and let's write designed by Zack Freedman. Nope, designed by Zack Freedman. Voidstar Lab in 2021 on stream. There you go. History's been made.
Right, so we want this to be put on the T place. T place is sort of like a general purpose, silkscreen layer. Yeah. So we're going to increase the ratio, which is something I really wanted to do at engineering school. It's basically the thickness. Thick. Change the size a little bit so we can fit it right in here. And there we go. Let's save that. Let's go back to Osh Park. Let's cancel and let's upload the new one. That should be all the problems fixed. So let's see. Obviously, hopefully there's a way. Veldork says you don't have a small army of lawyers protecting your copyright. You must not care about your copyright. First off, that's making an assumption. Second off, part of the reason copyright trolls and patent trolls exist is because it doesn't take a lot of work to it doesn't take a tremendous amount of work to enforce when I say enforce, I'm going to say enforce a copyright here, but what I mean is like to enforce the law on a copyright. It's pretty rare that, I don't know, generally just putting up any fight at all will get the person to, putting up any fight at all will generally get them to go away and find an easier target. Sometimes they'll try to extort a settlement. Then he'll say, like, come on, buddy, like, you know it would cost less than that for me to litigate this. Like, I'm not giving you $2,000. I'm not giving you $10,000. Like, it would cost less to go to court. Plus, like, you searched GitHub for this, right? Like, you have a bot that's scraping GitHub, that's finding orphan projects and trying to sue the creator. Like you got 500 of these things going. You don't, like, just move on. It's happened before. Sometimes it'll work. So let's take a look here. So this looks better. Not totally clear where everything is, but that's fine. I think it's unlikely this is ever going to be redone. So we don't have I didn't put a box around the capacitor, but that's fine. It's not the end of the world. There's a line here showing the polarity. That's the part that matters. Yeah, that's the part that matters here. You know what? Let's just fix that real quick. Mark of a professional is that no matter how tired you are, no matter no matter how tired you are, no matter how little it matters, no matter any of this stuff, you always do everything possible to get the best possible product. It's the mark of a professional. So I'm basically tracing this. Oh, I traced out of the B place onto the bottom. That's fine. We can just go to change layer, change the layer to T place. Okay, so you notice that the polygon is solid. That's not what we want. We want it to be... hang on a second. No, we can't use a polygon. I'm wrong here. We have to use a wire. There we go. I like, as I said, I'm a bit rusty with Eagle. Here we go. Okay, so we've now copied that onto T place. Copy that onto T place. The sort of general purpose silk screen layer, and I'm just going to bulk up that polarity indicator a little, make it easier to see. You'll notice here's another bit of professionalism. The corners are rounded, right? Like, it takes nothing but conscientious. Like, it doesn't cost anything, doesn't take any time. It takes nothing but having conscientiousness to not cause whoever has to open this thing later to cut their hand open. It doesn't cost you anything, but it just shows that you care about your client and you're thinking of their best interests. There we go. I'm really big on that crap. Why am I getting emails? Oh, a whole bunch of new filaments showed up. I have to stop ordering filaments. I have far too many of these. I think we have to do an episode where I'm doing nothing but respooling filaments. Let's see. There we go. Alright, I think this is pretty solid. This trace, you know what? Made another boo-boo here. It's not enough here. This trace here is a little too close. Not enough to not enough that's likely to cause a short, but there's no reason to roll dice that we don't have to. So let's save. Let's go to. Oh, did I just close the window? Wow, that was friggin' smart. Anyone figured out why I need a convection oven or a convection toaster oven yet? Let's see. Again, like if you're doing a project for a client, you should, like be a friggin' professional. Even if you're doing it as an amateur. Yeah. Ian Ross says, when can we expect every filament too? It's not going to be the next episode. It's not going to be the following episode, but it'll be the episode after that. I was planning on making it the following episode, but I realized that there's just too much to print and it's too difficult. There we go. Okay, this is looking solid. This is looking pretty good. All right, I think we're in business. Designed by Zack, Freedman, and Voidstar Lab on stream. I think this is pretty sound. So yeah, this is Fusion Mandala, pullin, is rotating art piece, driver board. Needs teensy 3.x and Lalu MD 39 a driver. Let's enter my email address. Oh no, everyone knows my email address. It's not like I put that in public all the time. Achillia, thank you so much for the super chat. It's so generous. I returned from getting new filament, and Zack is talking about getting filament deliveries. I know. That's our secret. We're always buying filament. About your board. That's looking alright. Looking good. In the next part, it's going to show each individual layer to make sure that we've got our drills. So, drill slots, yada yada yada. Supported slots will appear. Top solder mask looks fine. Bottom solder mask is fine. Silk screen looks good. Board outline. There we go. That's our slots. Yeah, this looks all right. Alrighty, let's place the order. Let's do it. So yeah, we want some circuit boards. We have to order in multiples of 3, and my rule is you always order. So we need 20 of them, and you always order 2 extra or 20% extra, whatever is larger. So we're going to go 1.2, so we're going to order 24, which just so happens to be a multiple of 3. What are the odds, right? So let's see. Our 2-layer prototype boards faster. We always want the speed. You never know what 2 or 3 extra days will be worth. So I don't think we have a coupon. So let's see. We got 4 to 5 business days, and shipping is. Let's see. Let's see the shipping. Check out. Come on. All right, so we got 24 of these. We want them in a hurry. This isn't our shipping address anymore. I actually keep forgetting our mailbox address. Brooke is asking, do you want me to go get your filaments? If you feel like you need a break, go ahead and feel free. There's some pretty neat filaments in there, but it's not a high priority. We're not necessarily going to use them for this stream. So yeah, I got a mailbox. So if you want to send me your crap, we're going to do a mailbag episode at some point. But I keep forgetting my own address. So yeah. Feel free to stalk my old place. I don't even know if there's anyone living there anymore. The place is kind of condemned. But yeah, if you're interested in sending stuff for you to show up to, if you're interested in sending me
electronics or 3D printing or really anything interesting to appear in a future stream or future episode, then feel free. Because I finally got a mailbox. And let's see, 8031. Let's see. I don't want to. No one's allowed to know my phone number. Let's get our shipping. Maybe it'll go on a shipping ship that's shipping ships. Let's see. ETA is 5 days on free shipping. We get overnight. Let's see. FedEx overnight is only $20. Yeah. Priority overnight's only $20. Yeah. Again, like $20 to get it 4 days earlier is 100% worth it. You've no idea what those 4 days could be worth. You put something off for a day, and for all you know, you might be putting it off forever. So, let's see. Fortunately, you guys are going to have to stare at this board for a sec, because I can't show you my PayPal information. Is that an OPSEC issue? I don't actually know if that's an OPSEC issue. I'm gonna say it probably is. Oh, there's a CAPTCHA and it's being blocked by the webcam. I just can't catch a break. I'm not a robot. These stupid CAPTCHAs, stupid idiots. They don't know anything. Am I Zachary? I think I'm Zachary. Yes, I am. I am indeed Zachary Freedman. Shh! Don't tell anyone. Okay, that's it. We are done. We're done with this part. All right, order is placed. All right, so yeah, let's open up our checklist. That's it. We have ordered circuit boards. All right. Very, very nice. Alrighty, let's take a quick take a gander. Did I miss a super chat? I certainly did. Did I miss 2 super chats? This webcam is really getting in the way. Brooke says, "Don't dox us." I am I'm trying to was the phone number in there for a frame? I gotta get a business phone number. I'll go back in afterwards and blur it out. Yeah. I honestly, I don't think it's impossible to get my phone number. I don't think it's possible to get my phone number. It's Voidstar Labs' phone number. It's Google Voice. So worst case scenario, I'll just burn it and grab another one. It's not like I have it's not like I have clients who have to keep in touch with me anymore. So okay, next step. Oh, we have a super chat. Totally forgot. Juan Fino, thank you so much for the generous super chat. Do you believe power armor from Fallout is possible in real life? The short answer is yes. The long answer is it's not worth it. The short answer is yes. Like powered exoskeletons already exist. The problem is that it takes so much. Basically, most of the energy of your power supply is going to be spent carrying the power supply. So you combine that with it's going to be carrying itself, basically. Like most of that energy in the battery is going to be spent carrying the battery, carrying the motors, carrying the frame, all that, and it doesn't leave a lot of mojo to carry armor. The question is why you would want it. Like, if the whole idea is just for a troop to storm into just an urban area and just start mowing people down without worrying about getting shot, just send a drone in. Just send a drone to fly overhead and bomb. Hell, it would probably even be cheaper to send a drone to crash into people. Honestly, though, there's no... similar things... I did a bunch of research for an episode that never came together about... did some work for an episode that never came together about... what was the name of the program? I think it's... I think it was like the Future Warrior Project, something in the neighborhood. And the whole idea was basically give infantry super high-tech gear. And
you're better, like, if you're going to spend that much on infantry, you could instead spend that on recruitment and just get new infantry. Like humans reproduce. You could also, just give them, you put them in vehicles. It just doesn't matter. You don't need infantry to have that level of power. Like, you can just, instead of having someone storm a building, right, just mow down the building. Like, it's the nature of the game, right? Like, if you're thinking about you can contrive some, like, oh, we got a hostage situation, they're taking hostages. Like, you just give them what they want and deal with them afterwards. What's going on here? QWERTY, thank you so much for the super chat. Really appreciate it. Really appreciate how easy your name is to type. QWERTY asks, where do you get your filament? Well, at this point, we got our filament from everywhere. Everywhere. Oh man, we got filament from Amazon. We got filament direct from manufacturers in Europe. I've had stuff shipped in from China. I got stuff straight from manufacturers in Long Island and Ohio. If there's a place that sells filament, there's a pretty high chance that I've got some filament right now made by them. Because when I say every filament for the next episode, I mean every filament. We're going to cover everything. So we got filament from all over the place. That's why I need the toaster oven. See, I bought a food dehydrator to dry out the filament. Filament takes on water over time and becomes unusable. So you need a dehydrator to drive off the moisture. It's not enough to just put it in an oven because the water will just evaporate from one bit of filament and just get sucked up by the filament next to it. So you need to blow air through it to constantly get that humidity out of there and keep it from just reintroducing itself. So I bought this food dehydrator to dehydrate filament. Problem is, we've got high temperature filament, and the high temperature filament needs a higher temperature to drive off the moisture. This temperature not only... Alright, so there are two things going on here. The first is that this temperature... Some of these filaments, the temperature I have to bring them to dehydrate the filament, is higher than the printing temperature of regular filament. Like I think peak, in order to drive off the moisture properly, you have to bake it at 250 Celsius. You have to bake it at just to drive off the moisture at a higher temperature than you print PETG. Like, in order to do this properly, we're probably gonna have to dehydrate this close to 275. Basically, like, hotter than I can even print right now safely print on my printers. So yeah, that's why we need the toaster. That's why we need a convection toaster oven, because the food dehydrator is not even close to hot enough to drive the moisture off of these. This also means that I have to get my hands on a metal spool, because this temperature is hot enough to melt the living heck out of the spools themselves. So these high temperature filaments are going to have to be re-spooled onto steel spools, or at the very least, like, transferred onto like a piece of pipe or something, so the spool doesn't melt while we heat them up. And I've had a really hard time finding a metal spool. So if anyone knows a good place to get a metal filament spool, please. All right. So the next step in our process here is we have to test. Got to test some stuff. In particular, the thing that we got to test. All right. Over here. These things are so heavy. Things we gotta test is that our scheme. There we go. We got to make sure that our scheme for keeping this battery alive is going to work, and we also want to make sure that it's not going to draw too much current. So here we go. Let's open this up. So this is our shipment from Palalu. We've got 20 something stepper motors. Yeah, these are 4 volts. These are 2.8 volt stepper motors, which doesn't mean like you can run them at a higher voltage. This is just the voltage at which they produce the most torque, I think. Basically, like, these are motors that'll work fine with a USB battery pack. It's similar to the motor we already have in our prototype, except it's just got slightly different characteristics. It was a little cheaper, a little bit lighter. I kind of overspecified the ones before. So in here we've got a whole bunch of drivers. Yeah, a whole bunch of drivers. We don't need to worry about these right now because we already got our prototype. Let's switch back to. Let's see. Oh, Jesus Christ! It's so heavy. So in here we've got our batteries. As it turns out, 27,000 milliamp hour batteries. It's quite heavy. I picked this box up, and then I picked this box up out of our package delivery hub. Then I realized I couldn't carry it back to the apartment, so I had to wait there with the dog like an asshole. Well, Brooke went and grabbed the car, and the dog was so sad. It was like, Brooke, why are you leaving us? I'm not doxing myself, Brooke. Alright, maybe a phone number showed up for a frame or two. So let's see. So we've got battery packs. The reason, so this is a higher capacity battery than this, because I don't know if this is gonna draw more. I don't know if, like, the way we're doing the current, I don't know if the way we are trying to keep the current draw high enough that it runs is gonna draw more. It's gonna draw more power, and still, this thing still needs to last a month. So, yeah. So the reason why we're using USB-C is because this guy includes 2 USB cables. One of them, we're going to need to charge the devices, right? And that's going to be the that's going to be this one, USB to USB-C. That's what we're going to use to charge the batteries. And the other cable that it comes with is Type-C to Type-C. So that's why we're sticking with using Type-C. Yeah. So yeah, that's why we're doing that. Alrighty. So looks like our battery shipped already powered. So let's hook up. Yeah. So we don't actually. We don't actually need. Let's see. Right, we don't need to actually attach the disk to this thing because we want to test this at the worst case scenario. We don't want this thing to shut off, we don't want this thing to shut off in any circumstances. So we want it, if it can work unloaded, it'll definitely work when it's loaded. So yeah, we're gonna let's actually switch over to this guy here, so you can watch as I do the spring terminal thing. And that'll also give me a chance to lower our overhead camera. There we go. Because I keep lowering the overhead camera while it's running, and I know that makes some people nauseous. So yeah, if I really cared, I would crimp ferrules onto these, but we're not going to. We're just going to shove bare wires into there. I think for the real deal, we will trim the wires down to size and tin them. But yeah, like, we're not at that point quite yet. We'll trim the wires down, we'll tin them. It's not as durable as using ferrules, it's not as secure, but that's fine. Like, there isn't going to be any strain on the wires. So yeah. Oh yeah, Roscoe the dog now has a forever home. I know. I miss the little guy, but at the same time, he's really annoying. Nah, I'm just kidding. Roscoe is a great dog. Yeah. Roscoe is. What I'm doing right now is just moving over my my schematic, so I can see which. See which pin connects to which. See which color connects to which pin. Let's see. That's not what I wanted at all. Oh no! Undo! The friggin' webcam is in the way. This is so annoying. Okay, so we got this. All right. Cool. So we could not give Roscoe the best home because, I mean, look, we're working constantly. We're working constantly. We don't have any other dogs. There we go. We're constantly working. We don't have any other dogs. Like, Roscoe is just not going to have the friendship, companionship, stimulation he needs. So, even though he was a very good dog and very smart and had a real personality to him, he just wouldn't live a very fulfilling life here at the Freedman Joneses, at the Freedmoneses. I know. Brooke and I were sad to see him go, but now he is living with a vet, so he's going to get to meet lots of dogs and have a big backyard, so he's going to be able to run around all day. And he has another dog, so Roscoe is going to get a dog friend. Yeah, Roscoe is going to have a little puppy pal. All right. So I hope I've got this hooked up right. I suppose we'll know soon enough. It doesn't matter if we hook this up backwards, it just needs to run. If we hook it up backwards, no one's even going to notice. Because it's moving in random directions anyways. So, yeah. Let's, what do you say I grab a USB cable and plug this guy in. Give this guy a little plug, a little pluggerino, a little pluggeroni. We are going to plug this into my power. So I've got a special USB power bank here that individually protects and isolates each port. So unlikely to burn anything out. Although we might draw too much current. We'll see. Let's see. So this thing should run. Anything heating up? Anything heating up? No, it is moving. It's just moving very slowly. It's barely see it, but it is definitely moving. Let's switch back over here, so you can see that this thing is moving really slowly. Let's grab some tape. Pull a flag on this. Let's see. Yeah, so you can see it's moving very slowly. This, believe it or not, is actually faster than this thing needs to run in real life. But, okay, good. So, sanity check, we know it works. Let's just confirm that the power bank can power it. Is this oh no, is this charge only? Did I make a huge mistake? I think the USB-C port here might be charge only. The motor driver is a little warm, which is kind of worrying considering how little load is on this battery, or is on this. Okay, I made a minor mistake. Well, I mean, look, this is the nature of the game. This is why it's so risky. What? Yeah, I mean, look, this is part of the prototyping process. You got to make the best decision you can and figure out, how to deal with the consequences. Worst case scenario, we just return all these power banks and, that's that. So it looks like we can't power this thing off can't power this thing off the USB-C. So let's see. It's warming up. It's still working, though. It's working here. We just don't... I had hoped that we'd be able to use the Type-C to Type-C instead of this. So we're gonna have to buy a bunch of USB cables so that so the pullin can recharge these things. Motor driver is getting a little warm. I wonder if I might have something hooked up wrong, because it's still turning. Yeah, we gotta work on the code a little bit. It seems a little bit choppy, but yeah, it's turning and it's working. It's working off of this. So here's the question: how long is this going to take to turn off? How long is this thing going to take to turn off when there's no load on it? That's what we're going to answer right now. Unfortunately, there's no way around that. Unfortunately, there's no way around that except to time it. So, yeah. I guess I'll answer questions for... So the other one took 2 minutes. Let's see. The other one took 2 minutes, so we'll see how long this takes. Reset the timer, start timing, and leave this window open while... let's get this down here. Leave this window open while we check... while we take a look at chat. Yeah, so this is a great time to say hi to chat. Aerator says a lot of USB C devices cannot charge with a C-to-C cable. It's insane and a massive disgrace. No one knows what they're doing when designing USB-C boards. This is the opposite problem. This provides power using this charges through a USB-C cable, but it won't provide power through the USB-C port. And I thought the instructions said otherwise, so I'm actually quite disappointed here. I am not amused. Aerators, Brick Pixel says, what Palalu drivers are you using? A lot of experience with a range of them. This one is the MD39A. It's MD39A. And the art piece is, the art piece is a, it's like, whatchamacallit? Man, I'm very. I was tired. I was tired before. I was tired yesterday. I only got like 6 hours of sleep, which is not a lot for me. It's a transparent disc with like all kinds of like mixed media and like neat textures and stuff on it, so it can rotate. And this thing rotates it. Very, very careful. Oh, it went off already. Oh my. All right, so let's see. I might have missed it. I thought usually it's much faster. So let's see. Yeah, usually it's much quicker. So we'll keep it. But now we know it's at most a minute or so. Mindspeed 200 says, isn't bidirectional power part of the USB-C spec? There are a lot of things that are part of the USB-C spec. Yeah. Yeah, the USB consortium doesn't enforce the name the way like HDMI does. So for HDMI, you have to rigorously and comprehensively implement the spec, and you need to get licensed. It went off. All right, so it looks like we're holding it about 30 seconds here. This is not very long. So yeah, it's not very long. So anyways, it's not as like the USB isn't. They don't enforce it as well. They don't require you to get licensed. So I think they. I don't know. I'm inclined to think they should. So let's see. We're at 20 seconds. This is a lot faster than the other battery packs I tested. Come on. Let's see. 30 seconds. Is that it? 30 seconds on the dot. That's it. We got that's it. It's 30 seconds. Let's see. Victor says, "Are you sure it's not? Are you sure it's not a the cable? I suppose it could be the cable. So here, let's see. So this is a known working cable. This is a known working cable. This is one I use for my external for the hard drives that the Blackmagic camera records onto. So let's try this one. No good. Yeah, still no good. No, it's not the cable. Looks like we're going to end up with a lot of USB-C to USB-C cables. Reagan, thank you so much for your very generous donation and for contributing to our Patreon. I really appreciate it. Have you considered making your own power bank? Most just containers for 18650s you can gut from them and other lithium devices. Yeah, I talked about this a bit earlier in the stream, but for this particular project, it's... Why is there a green LED? What's that all about? What's this green LED doing here? What's that? What are those? It's not justified for this project. Is there a way to like keep this thing on longer? Is that what that does? It's just not justified for this project. There's no reason to do so. It doesn't make it any. It doesn't save any money. It doesn't save any time. You know. So yeah, there's no reason to just use. There's no reason to do engineering unless it's necessary. Usually you're better off just buying engineering if you can get away with it. But I appreciate the super chat. I appreciate appreciate having me, justify myself instead of, instead of just following my assumptions. Yeah. Reagan says, I just meant for a project. I actually do have a plan to make a USB battery pack for an upcoming project. Basically we're making the idea is to make a cyber deck and to make each part of a cyber deck. Basically make a cyber deck and make each part of a cyber deck its own standalone device. So the keyboard will be a keyboard, the keyboard will be a keyboard, the power will be like a power bank, and all that good stuff. I think this just keeps the battery on. I think we're in business here. Folks, I think this is I think we're in business. Yeah, this is not turning off. This is not turning off. I think the thing to check is if we put the teensy into sleep mode, is this going to stay powered? Yeah, I think this is pretty neat. I've never seen this before. I wonder if it'll stay on in this mode. Yeah. I wonder if it's going to stay on. I'm just going to leave this thing I'm just going to leave this thing with the green light on, and we'll see what happens. See if it turns off on its own after a while, or if it just keeps running ad infinitum. In the meantime, which camera do I have? I hope it's this one. In the meantime, let's try to load. All right, looks like we broke the trace between VCC and ground. Very smart. We don't want anything back powering anything. So let's head back over to the computer. Oh, there we go. Let's head back over and let's put this teensy to sleep. Yeah, let's put our teensy to sleep. Why is this upside down? Why you do this? Why do you do this? You just can never get through an entire... Alright. We're going to do some code. It's a little boring. Don't worry. It'll be quick. It'll be over in no time. Don't you worry. So here's what we're going to do. We are going to switch over to using the Teensy 3.2. Tinsiduino. Now let's crank up our font size here. Yeah, Teensy. I think it's this one. 50-50 chance. All right, then we're just gonna open up the default sketch, or we're just gonna open up the demo sketch. to put the thing to sleep. I think it's called snooze. We do this. Deep sleep data logger. Is that it? Button hold wake up. I don't think that's the one we care about. Just want the basic one. Like, what? Crap! I haven't even thought of this. Sleep USB serial. That's pretty interesting. What's the difference between deep sleep and hibernate? Let's look this up real quick. I don't actually know these off the top of my head. Teensy sleep modes. Snooze. Let's take a look at the README. There's a maintenance update, yada yada yada. How? Here we go. Use the we got various modules to wake the teensy. Oh, that's pretty interesting. So, how do we do this? What are the different sleep modes? This is laid out horribly. Doesn't say what these do. I guess we're on our own to figure that out. I guess we need to look. I guess we need to look up what the chip is in the teensy and pull up its data sheet. Let's see, I keep forgetting. Let's pull up that data sheet. Let's see if we already have it. MK2. Ah, there we go. That must be it. Ah. There we go. Oh, I definitely want folks to see this file. All right, so let's take a look. Let's look for hibernate. Searching all 1,400 pages. All right. How about deep sleep? All right. Normal run, normal wait. Okay, so not only did he not explain what the various sleep modes are, he made up new names for them. Awesome. Great job. That's definitely going to make people use your library. So we have sleep, we have deep sleep, and we have hibernate, and I have no idea what those do. There go the viewers. Let's open up. I think the library is called Snooze. Let's open up the. It's not even indexed. Jeez. All right. So let's just open up the file and open up the header file, and maybe they got some docs there. All right. So this is going to be in library. Oh, it's not even there. It's going to be in it's going to be in Arduino itself. So, is it? I think. While we're here, we might as well just double check. Libraries. Nope, it's in Arduino itself. Where does Arduino store its libraries? Is it in app data or is it in program files? I think it's in app data. See, users, ... roaming. Nope, it's not here. Let's see, Adobe, Android. We have Arduino. We don't have Arduino 1.5. Is that it? Packages. I don't even know where the libraries are. I think it's in program files. See program files. I suppose it's not. Is it an x86 app? Yes, it is. There we go. And it's not in here either. Oh my god, this is so annoying. This is so annoying. Let's see. Teensy sleep modes. Let's see. The sleep mode. Let's see. Alright. This response is in French. That's very helpful. I too like to go to forums in other languages and answer in English.
snooze, I guess we should just pick one. Doing snooze 1.5 milliamps. Alright, so I guess we'll use this guy used deep sleep. I guess that'll work. I don't know what hibernate does. Let's see. Here we go. Oh, there we go. What's the difference? Sleep, deep sleep, hibernate, yada yada yada. Being the same mode, but hibernate puts the regulator in low power mode. Sleep for 5 minutes. Use the RTC. Okay. So we don't have it. So we're not going to use the RTC. Reagan says hibernate puts the USB regulator in low power mode, only able to supply limited current to the 3-volt output on the Teensy. How does that work with voltage in though? With VN? I guess it doesn't always matter. Yeah, hibernate puts the USB regulator in low power mode, only able to supply limited current. So I guess, is that going to cause the motor driver to explode? Can we power that off of? Can we provide motor power without providing 3 volts? I think we probably could. Yeah. All right. Let's give it a shot. Let's do some Let's do some hibernating. File examples. Snooze. Hibernate. All wake ups, I think. All right. So we've got a whole bunch of different things that can wake it up. Alrighty. So what's this? Oh, all right. So we've got digital pin. All right. So we got some digital interrupts. All right. Does the RTC need a crystal, or will it run without a crystal? We don't care. Anyways, we're using the timer. Okay. Awesome. Okay. So this is all of them. Yeah, I imagine this is not going to have a tremendous amount of noise on these pins. So let's just make sure we're not. Yeah, there's no inputs, so I think we're fine. So let's load her on up, see what happens. So if this is working properly, I take it the LED should blink. I take it that the LED should blink. Victor asks, do you have an older version of the project? You can go to an earlier release of the repo and look in the README there. I'm not going to... I guess it's possible. Alright, so let's take a look. Looks like we're blinking. So it looks like we're going... looks like it's off. It's blinking 1, 2, 3, 4, 5 times. Is that what it's supposed to do? Oh, Yeah, it looks... Oh, so different numbers of blinks mean... Oh, I get it. Alright, different numbers of blinks mean different reasons why it woke up. That's pretty cool. 4, 5. Okay, so... And question is, can you see the... yeah, you can clearly see the blinks. 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi, 5. Alright, close enough. So it looks like it's... So, yeah, it's blinking 5 times. So that is our LMPTR. What's LMPTR? What's that? Pin wake up source RTC. LPTMR. I'm guessing low power timer. Yeah, I'm guessing low power timer. So yeah, let's configure the timer to a really long time. If defined IMRX. Alright, so we know this thing shuts off, so we know the power bank shuts off after 10 seconds, or we know it shuts off after 30 seconds. So let's set this to 1 minute. We'll upload that. Yeah, and then we'll upload that. So we're currently, we're powering this off the USB power strip. So are we? So this should stay off for a while. Wait, why didn't it stay off for a while? Come on, upload. Oh, is it not going to? Oh, no, there it worked. 1, 2, 3, 4, 5. So now it should stay off for 60 seconds. No, it didn't. What did I mess up? 60 seconds times 1,000. Right? Maybe it's this. It should upload because it's got the USB. I remember doing something. I remember doing this on the Singularitron. There we go. It might not have uploaded because. Oh, yeah, I think it looks alright. It might not have uploaded because it was sleeping. It turns off the USB when it's sleeping. All right, so it looks like this is working. So we're going to. So let's unplug this from power strip power. Let's unplug this just to prevent any confounding variables, and let's plug this in to our power strip or our USB power bank. So if this thing keeps on running, there we go. So if this thing blinks without this, if this thing blinks twice, then we are in business. This thing goes through the blink routine twice. Yeah. Then we're going to be in business. So let's just make sure that happens. If we don't even need to modify the code, that would be awesome. That would be great. That'll be rad. Unfortunately, we got to take our licks on this one because we can't avoid the coding. We got to do a little programming. Wafflemancer, thoughts on Platform IO versus Arduino IDE? I get asked this question a lot. I don't have time to fight with new tool chains, so for now I'm going to stick with whatever works. And I got Arduino working, and that's it. I don't want to have to. Let's see. Yeah, I don't. Yeah. Yeah, I don't want to have to do much fighting. Ted Milker says power bank was still on too. What I'm concerned about is if it's in some sort of low power. What I'm concerned about is if it's in some sort of low power mode, basically like waiting for current to rise, and just want to make sure this is actually gonna do it because we can't. Yeah, I want to make sure this is actually, when it gonna work. Let's see. There's no reason to trust any of this stuff. Just because the power bank has lights on doesn't mean it's providing power. Just because it's providing power doesn't mean it's providing enough power to run the Teensy, or that the Teensy is gonna run properly. So let's see. We should be coming up to about a minute. We should be seeing some blink in action. I'm actually gonna switch the light off here, and by switch it off I mean unplug it. Pardon the vibration. There we go. Blink, 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 blink. If we can get one more, then I'm feeling good. We don't even need to worry about this complex bit. Wow. This thing costs like half of what the special voltaic one cost. So yeah, if that thing can power devices while it's being charged, then there is no reason to ever buy one of these again because that has all the same features. Inus3322 doesn't the power bank have a manual? Yeah, let's see. Again, you can't necessarily trust the manual. They might have changed the product since they wrote the manual. The manual might be baloney. Sometimes they might make a false claim to get better reviews. Who knows? Low power mode. Use this mode for low current devices like smartwatches, bracelets, etc. To enter the mode, press function twice. The green indicator lights up. To exit the mode, press the function button again. When the load current is less than 80 milliamps and duration exceeds 60 plus minus 30 seconds, the product shuts down and enters sleep mode. This is actually pretty comprehensive. So it doesn't say how those two interact, but I'm assuming it works. This should blink like now. 60 plus minus 30 seconds. Isn't that exactly what you want to see? Yeah. Yeah, it looks like we can use the internal. We don't need a crystal. We can use the internal timer. Is this thing still? Is this thing on? Yeah, let's... Cooper G says, I'm watching the stream while assembling my Prusa i3. Great way to pass the time. It's a great printer. Yeah, that's pretty much what I did when I made my first one. Just, like, put on YouTube and... I don't think I watched... Oh, blinked! Alright! Kick ass! Very nice. Alrighty, there we go. Cool, cool. We are in business. Awesome. Okay, so we don't even need to write any code. Huh. That's great. Why does it always blink as soon as I like, you know, be a good citizen and read my chat? Okay, so we're in business here. This looks solid. So, yeah, we can just put this thing in. Here's the question: can we trust Pauline or whoever or the gallery, whoever is actually running this thing? Can we trust them to follow directions and push a button twice so a green light is on? Probably. I don't know. I'm very conflicted about this. Because on one hand, it'll work. On the other hand, they're going to have to remember to push that button, make that light green. Maybe we should use... Maybe I'll end up using, like, the 3D printer or laser cutter to make, like, a label for it and say, like, do not install unless the green light is on. Press the button to turn on the green light. Oi. Cohen Cornell says, I bought and built a Prusa Mark 3S this last weekend because of this channel, and it was much harder than I anticipated. Oh no! Cohen says, so much harder than the Ender 3 build. Okay, well, the Ender 3 ship's mostly assembled. the Ender 3 only has, like, 7 parts in the first place. So, yeah, it's, yeah. I think we'll stick with that. So, I think I'll stick with that. So I'm just thinking, okay, so our stuff works. We've tried the new motor. We've, like, granted, we haven't hooked it up to, the disc itself, but I suppose we could. I don't think it's totally necessary. I think I'll make some labels and stick it to it. Yeah. Okay. So let's think here for a sec. Jeez Louise. I'm forgetting what all my buttons do. All right. So the remaining tasks are, we have to put this in, we got to put this all in a 3D printed enclosure. We got to write a little code. We have to figure out how we're going to actually attach the art to the spindle, because I have a limited amount of control over that, but a limited amount of control over that, but I can't make them do anything complicated. We can't have any fasteners visible. This has to look clean. So how are we going to? All right. So I think testing components. Let's update our to-do list here. I think our parts are going to work. I'm pretty, like, granted we haven't tested the motor yet, but considering it's so similar to the previous motor, and the previous motor was so overspecified, I think we're alright. So, yeah, let's move on to 3D modeling. So we have two choices on exactly what to 3D model. The first is the little bit to keep the disc attached to the motor. The second thing that we need to model is the thing that mounts all to the wall. I'm thinking we do the first one because it's faster, because it can get us going. Sooner. So yeah, let's Brooke, if you are listening and you are here, do you think you can grab the disc? The disc is near our front door behind the boxes the dog liked to chew on. The power supply here is Amazon brand. If you'd like, I can link it in right now. Let's actually do that, because yeah, I probably should have done that first, right? Because then folks can look over my shoulder and I can get affiliate revenue. Yay! Here, let's link that. Let's link that in so folks can see what's going on here. Monkey Boy asks, who made the LCD for the 3D printer? I bought that on AliExpress. The company, the brand
as it were, is Wise Cocoa. I actually really like it. I actually really like the. I like the form. I'm surprised. Surprisingly love the form factor, and it just works pretty well right out of the box.
I got you this.
Hey, there we go. I'm gonna cut this part off, or I'm gonna scribble this part out because it's got my phone number on it. Because this thing used to be in the Fab Lab, and I put a sign on it to make sure no one would take it down because we're running some tests. So, yeah. So this is the approximate size and weight of the art piece. This is This is basically it. What? So yeah, we've got this big acrylic disc. The real deal is actually going to have a bunch of stuff stuck to it. I'm just, like in our calculations, I just assumed that was going to add an extra 5-10 kilos. So, yeah. Let's take the sign off. So it's got holes drilled in the center. This was one of my previous attempts to create some friction by sticking a piece of tape on there. It didn't work very well. So the art pieces are these about 1 meter in diameter. And they got a 5mm hole, I think, I'll measure it, drilled in the middle. And there's not much else we can do here. We can't have them machine something fancy like machine a flat in, because we can't have them modify the art pieces because she's already made the pieces. So yeah, we're gonna have to make it work with this. So yeah, I gotta figure out how to do that. So what I'm thinking is, we'll have a back piece like a spacer that spaces it out from the. Why is this running? Wait a second, something's going on. Was this just running? Why is it warm? Hang on a second. If this is in sleep mode, shouldn't the... It's hard to... I'm having a hard time turning the axle. If this thing's in sleep mode, shouldn't it be disabling the power supply? And shouldn't that be taking down the... Wait a second. I'm confused. Ablative Kitten, thanks a lot for the super chat. Really appreciate it. Welcome to the stream. We'll deal with that in a sec. Okay, we're losing viewers. We have to move forward. Okay, plan. Add a spacer to the back to keep it from scraping against the wall or the thing that attaches to the wall. And I'm thinking we can make maybe something on the. Maybe we can make something on the front that make a thing. What's a way of saying it? Make a little ferrule type thing with flexible filament, so we can jam it on and take it off. Maybe like friction fit. I think that could. I think maybe that could work. I think that could work. Someone suggested magnets. Magnets might be. Magnets might be an option. Yeah. We could, maybe we could do some magnets. We could make like TPU parts front and back with magnets on them that stick together. Yeah. Do we just want? Let's see. Do we just want to? Yeah. This is the problem with doing something like this on a stream. It's and whenever I stop and think about something, you get bored. So, yeah, there we go. Okay, alright, we gotta lock this down and move forward. Okay, plan. We are, actually, I just want to test something real quick. This could make life a little easy. If the fit between the shaft of the motor and the hole in the center of the piece is pretty tight, then, yeah. Alright, so this can't really... So this is wobbling a little bit. So the question is, could we make like a cap that goes on the front and a thing that goes in the back and put magnets on them? And, put magnets in it, so it... basically, that'll provide the friction. and we're just counting on somebody not grabbing this and pulling it off. Because it'll come right off. Then again, like, if you go to an art gallery and grab the art and yank it off the wall, it's going to come off anyways, right? Because it's just, it's just held on by a little, hook thing on the wall. So I think that should be all right. Let's take a look at our magnets. Let's figure out which one we're going to use. How do they work? Alrighty. So we got a whole bunch of different magnets. Actually, we should probably be doing this over here, shouldn't we? So, yeah, we got a whole bunch of different magnets. I'm thinking these guys here, these like rod-shaped magnets, they're fairly powerful, and because they're deep, we can fit more of them. Like maybe we can have like 8 or 10 of them around it, and then you just grab the bit and yank it off. I think maybe we could do some of those magnets. Could also use maybe some of these guys. Maybe stack a few of them up and put them in each area. I don't think we want to use big discs like this because we want to cover as little. We want to like cover as little of the. Let's see. We want to cover as little of the art as possible. So the less we can use, the better. Leon says, "Look at the grub screws that people use with motors." We can't use grub screws. We can't use grub screws because it's likely that the person who has to take this thing down to recharge the batteries won't have an Allen key. The original plan was to add a little recess in this so we can store the Allen key in the device itself. But I realized that once you mount the disc, you're not going to be able to reach back there. So there's no good way to do that. They could lose the Allen key. So I'd like to make this tool free. Yeah. So I think Everlanders, thank you so much for the super chat. Thanks for the Canadian pesos. He says, he or she says, say my name, Everlanders. So yeah, we got these magnets. I think these ones are the way to go. I think this is our boy right here. How many of these do I have? Can we actually make a prototype? Can we actually test this out? I have a lot of magnets. I use them all the time. I don't know how they work. Juggalo scientists around the world have been working on it for decades. And as far as I can tell, I haven't made any progress. What a fandom. I don't even think it's fair to say like groupies. I don't know. It's like its own subculture. The Juggalos. That's going to end up in the history books. Okay, so this is all the ones I have. Let's try doing some TPU. Maybe we can even try getting TPU going in the new printer. I'm sure I have a hard time believing it can actually do TPU, but we can give it a shot. I love playing with the magnets. I know I can't stop. All right, enough. We have to put the magnets away. All right. So let's do this. We'll make this out of TPU, and I think that should provide enough friction that we can get this done. This is a pretty simple model, so should be pretty straightforward. Let me think. Do maybe we want to add like some rubber or something on top of it? I think I'm overthinking it. We want to make this as I'm overthinking this. Yeah, we want to make this as simple as possible. So let me think. So we could make a thing with TPU, and like that. That can be. Let's switch this back. And we got the. We're not using 2 motors. So we got the thing with the TPU, and we might be able to friction fit it. We don't want it to bottom out, because then there will be friction between that and the motor. And there's no way to keep someone from mashing that down. So maybe we want to add a bushing. A bushing. Or we can print the back part out of plastic and add a set screw. Print the front part out of TPA for friction. I think that's the plan. We've lost enough viewers. We have to move forward. So let's go. Let's open up Fusion, which I thought I already had open, but apparently not. All right, so I'll make the back part out of plastic. Add a little set screw action in there. I don't think we'll use a grub screw. I think I'll use a. Yeah, I think we'll just use like a 3mm or like a 2.5mm screw. Yeah. Victor says seems like bad UX. Well, we're trying to do the best. Again, I have a limited amount of time, and I can't spend all day thinking about this because people on YouTube want to see stuff happen, and it's not fair to the viewers or myself if we are waffling all day. We have to take one idea and move forward. So, let's do it. Yeah. So, where's our calipers? Here they are. I dub the X caliper. There we go. All right. So will we be able to? Will we be able to do a decent job of this? Make the hole a little bigger. Yeah, I think we will. So let's make this about 30. We'll start off with a circle about 30mm. Maybe I should probably bring this camera over here so you can see as I measure. I need more cameras. Now it's looped around the mic. Let's see. Yeah, so we'll make it. I think start with about yay big, 30mm, give or take. Yeah, and then let's see. In the middle, I shouldn't be scrolling around. I should be using my space mouse. Haha. What did I do? All right. So this part we want to be a fairly tight fit on the shaft. So shaft is 5mm. So let's make this 5.5. I think that should be good. Let's turn this away. Yeah, I think this should be about 5.25. We want it tight, but we don't want it crazy. Let's call it 5, and we can always drill it out afterwards. Then we don't have to worry so much about. Getting our dimensions right. Yes, the thigh cam is back. Let's make sure my fly is closed. Yeah. All right. So we're gonna need that. And let's take a look at our magnets here. So the magnets are about 4mm. So we can make this a bit bigger because we're going to be gluing the magnets down. So we don't have to worry so much about getting those perfect. But here's what we're going to do. Let's see. Draw a construction line. All right, we're going to draw a construction line. Oops, let's get in here. It's vertical and touching this. All right, we're going to add a point there. We're going to get another construction line. And this one, maybe I should drop the density here. Make this easier to see. It makes it harder for me to use the software, but it makes it easier for you to see. And at the end of the day, you folks are what matters. So, yeah. Let's see. I'm getting all disoriented with the space mouse. I wish I could get the space mouse in frame too. Maybe I can. All right. So midway through this, we don't need this anymore. So midway through, we're going to add a hole for our magnets, and what do we want to call that? 4.5. 4.5 would give it a tight fit. 5 would give it a very loose fit. Let's call it 4.5. If it's too tight, you know what? Let's call it 5. Yeah, because too tight, like it's a long magnet. Let's go back to 4.5. Yeah, okay, so then we want to make a circular pattern. If it's too tight, then we're going to have a tough time getting the magnet. Let's see. We're going to have a tough time getting the magnet all the way in. So we can make, let's see, we can make 6. That gives us the option to experiment with 2, 3, or 6. I think the most we could do is, I think 8 looks reasonable. How many do we actually have here? We got 2, 4, 6, 8. So we can try with all 8. Let's try 6. Yeah, I think that looks good. All right, let's just do the 4 millimeters apart. I think that's a little much. I don't think this has to be 30. I think we'll probably get away with not 35, 25. Yeah, I think that should be more than enough. So that's 1 inch. I think we can lose 1 inch from the middle of the piece. All right. Because we also need to remember that we've got a set screw to jam into this. Let's see what we got. We got one of these. We got some of these. These are leftover screws for building the tool changer. I end up with a lot of stuff from the tool changer. So one idea is we could put in a slot for a square nut. The nut, and just leave an area for just slot for a square nut, leave an area for just a regular old screw to go in there. Alternately, we could use a grub screw, but that grub screw is gonna, I think it'll be a little awkward because it's gonna have to go all the way in. Yeah, I think that'll be kind of awkward. We're gonna have to drive it through like an inch of plastic. So yeah, I think this is about what we want. We have a little square nut, and we have a cap head screw. I think that's the way to go. So yeah, let's add that in. So let's see. Why is this giving me such a hard time? I'm so disoriented here. Probably the sleep deprivation and the burnout. All right, so we'll put this over here, and yeah, how big is our screw here? We're gonna want so it's 1.6, so we'll leave a slot of about 2 millimeters, and it's gonna have to be. Let's see, this is 5.5 millimeters wide. Let's see. This is 5.3 millimeters wide, so we'll leave a 6 millimeters slot. So we need this thing to be maybe like 2 by 6. Yeah, I think that's fine. So let's do a center rectangle, and let's make that 2 by 6. And this is a little on the awkward side. Yeah, it's a little on the awkward side. Maybe we want to make this. Would it help if this thing were 30? It helps a little. Yeah, what would really help is if these were closer to the edge. So let's do so. Let's make this 2.4 millimeters. I think that's good. I think this should do the job. How much room does this give us? 1.5 millimeters. It's not a tremendous amount. So let's let's do the same over here. The reason I'm adding these points is because I don't want, because like Fusion only draw dimensions by default from the center of the it will only draw from the center of a circle, but we want to draw from the edge of the circle. So yeah, there we go. Okay, and yeah, and this should leave enough room. There's not a lot of, we don't have a lot of room here, but that's fine. there's still plenty for the screw to bite onto. So, yeah. Let's move this guy over here and make life a little more comfortable. Alright, so how do we want to do this? We're going to... Alright, so... I got a lot to research afterwards. So, yeah, this thing... I guess, like, we should check out if there's even enough room for this. Looks like these are... Magnets are about the size of the shaft. The shaft! So, yeah. The magnet is, I think this is 8 millimeters long. It's 10 millimeters long. So, yeah, I guess this thing should be 10 millimeters as well, or do we want to leave room for it to bottom out? Yeah, it's always tricky. All right, let's see. So if this is 11, so if we size this to be 11 millimeters, then it'll end about here, and then then we'll have a disc, and then we'll have the thing on top. I think that's probably too much. I think we have to do this exact. Got to do this exactsies. So let's extrude 10 millimeters. Yeah. So we're going to be counting on the adhesive to handle the magnets. All right. So then we're going to want to extrude this. So this thing has to go up 10 millimeters. You know, this is. So it has to go to halfway up. So we have 5 millimeters because that's 10 divided by 2, and then we need the width divided by 2. My contact lenses are trying to go on an adventure. So we add plus 3 because it's 6 millimeters wide. Okay, awesome. So let's just make sure we have, let's see, face. Let's make sure our wall thickness up here is thick enough. 2 millimeters will do it. I think 2 millimeters is fine. Let's get that out of there. Okay, so this is the basics. We want to make a sketch. So now we want to add in a hole for the screw. So let's get our XZ plane, and let's project this pocket that we just added for this nut. There we go. Alright, so let's reconstruct our screw here. Yeah, we've got a construction rectangle. Bottom that out over here. And this should be, let's see. So this should also, that's not what we want. We're going to go this line. So that should be 6. And then we'll add a construction line here, and now we know where to put our circles for our set screw. Okay, so we'll use this as our set screw. Cap is 5 millimeters. We can leave a lot of extra, so let's leave. Let's call it 6.5. This should not be construction lined. And then for the threading. Let's see, this is an M3 screw, so it's nominally 3 millimeters. We want this to really jingle around, so we'll call this 3.5. We can always drill this out. All right, and last thing we want is, let's see. Last thing we want to do is, this should go a little higher. Is basically taper the top of this. Yeah, and this sort of tent configuration, so we don't have to use support material. Can't bridge geometry like this. So let's see. This goes here. This goes here. Let's go right angles. You can probably do 60 degrees without worrying, but I think they'll be fine. No one will see this, so it's fine if it looks a little grubby. Alrighty, so let's see. So the first thing we got to do is extrude this all the way through. No, yeah, there we go. Alright, so this is the hole that's going to go directly down to the flat of the motor shaft, so the screw can press against it and secure it. Yeah, we're not going to drill into a round surface. Don't worry. We need to also extrude the larger area. Oh, there we go. We need to also extrude the larger area for the head of the screw. How long a screw are we going to use? What do you say? What do we call, like 10 millimeters? Yeah, give or take 10 millimeters. Doesn't have to be this exact one, but it seems an appropriate amount. All right, so we are just going. So it's easy to do. We just offset it by 10 millimeters, and then send it through all the rest of the drawing. So let's just make sure that this leaves enough room. So to the shortest point, it's about 4 millimeters, and the head of our screw is 3 millimeters. So we're in business. Very nice. All right. All right. Now we have a minor problem here. Let's go this way. We got a minor problem, and that is that I haven't taken the print off of the printer. So yeah, that's a little on the awkward side. Let's see if this works. Let's see if this is going to work here. Oh, it's upside down. Oh no! So we got our printer cam. Yeah, check that out. Although it is upside down. Let's switch that back to. Oh no! Why isn't it? Oh, it's not working. This is not our best. This is not our best stream. Yeah, we need to adjust the printer cam a little. I realized that I never set up the. I never set up the other camera. Maybe we should do that. Maybe that's a smarter thing to do than messing around with our overhead camera. Yeah. Still collecting B-roll for. This is another problem. We don't have enough room here because the place is too messy. All right, I guess. Yeah, and I can't. This HDMI cable can't reach over there, so we can't use the capture card. Crap. All right. Well, I suppose there's nothing to do now. All right. So maybe if I move this like so. All right. So what I'm doing now is just removing the plate from the bed, removing the plate from the bed of the tool changer printer. I was running off another copy of the OLED heads-up display because I needed more B-roll for the episode that I'm doing about it. So I reprinted it, but in my infinite wisdom, I didn't pull it off before starting this stream. That was unpleasant. All right. So this looks like it's been playing nice. We have to figure out why it's not turning the stepper driver off. Let's switch back over to. Oh no, it's loosening. This system is jank. System is jank, and it's held together by duct tape and prayers. All right, we're gonna put the 3D printer scraper. I just threw it in the bin and then covered it with a bunch of other stuff. That was real smart of me. All right, so let's. Oh, it's drooping. Today I just cannot catch a break. Let's tighten this up. Come on. I guess this is why most people don't stream their jobs. Stop shaking, please. All right. Very nice. Oh, it's tilted. Okay, so yeah, this is tilted a lot like the developer. So yeah, let's get this off. It's a freshly applied layer of glue, so everything should come off nice and easy. Let's just loosen up the brim. Part should more or less come right off, and being very careful to avoid scratching the plate. Being very, very careful here. Don't want to scratch a plate. It's just PLA, but I'm still dialing in how high to level this. So it really got mashed in there. I'm glad I used the glue. All right, let's take a look at chat. Let's see what. Oh, have I missed stuff? Did I miss a super chat? It doesn't look like it. Alrighty. Okay. The printer is located in Australia. That's right. Brooke says the noise gives me anxiety. If the noise is too much of if the noise is an issue, I can mute the. I can mute the mic, or switch over to a different one. Come on, get off. There we go. There we are. I'm not sure if I'm actually going to rebuild this thing, or if I'm going to save the transparent LEDs for another episode, or yeah, another project, another day. There we go. Yeah, the video is turning out to be extremely funny. I know that's not. I know people aren't supposed. I know we're not supposed to we're not supposed to think we're funny, but I really like how this episode is coming out. It made Brooke laugh, and we know that when an episode makes Brooke laugh, it's a good one. So I'm just applying a little water to spread the glue back out. You can reuse the same glue for a few prints. I just want to spread it out so we don't have any glue-free spots. Alrighty. So then let's switch this back. Alright, let's put the plate back on. So we'll use this printer today. I'm trying to get as much use out of it as possible so I can fix all the remaining bugs. Soon we're gonna be switching into 24/7 boat production mode, because we have a tremendous number of filaments to get through. I put it up at this angle, or I put it over here at this angle so it would show up in the background of the video, but I think it's causing more trouble than it's worth. So we will reorganize this. Grab this thing and move it to the ground. It's really heavy. It's got to be at least 60 pounds, maybe more. Because I can lift 50 pounds easily, but this is giving me a rough time. All right, we want clips in the back corners as well. Come on, there we go. I don't like these clips very much. They don't seem very secure to me. All right. So we got that all plugged in, and let's grab our auxiliary camera. We're not going to be able to use it because we can only hook up one camera to the strip. I didn't think this one through, and this job, everything is hard decisions one after another. Yeah, let's see. Put the camera over here, and then so we'll move the camera over here, attach the HDMI cable, and use the capture card. Can the HDMI cable reach this far? Because I don't think we're going to need to do anything on the workbench anymore. So I think we should be able, yep, here we are, to just put the camera right here, And then everyone can see 3D prints. Turn on, please. Take off the lens cap. Let's switch over. Are we good? We're looking pretty sound. HDMI cable is knocking stuff over. I need a longer power cable for the camera. All right, zoom out a little bit. There we go. 3D printer cam. Oh, I just realized let's see, how's our picture look? I just realized it's the rainbow pattern is going really, really slowly. Because I was doing a time lapse, so I slowed down. There we are. Let's start from there. We're doing a time lapse for this video, and I slowed down the pattern of there we are. Of the rainbow fade, so it would look better on the time lapse. Otherwise, it would just flash and look terrible. Is this clear? That looks fairly clear. So I have to. So at some point, I've got to speed that back up so it looks cool. Very nice. What do we want to do here? Yeah, let's print this thing. Oh. I went through all the trouble of making these. Wireless macro pads, and I still haven't set them up to use them. There's not enough hours in a day. All right, let's do this. So we're going to go to Tools, Make. We're going to make this, and we're going to send it to Super Slicer. Let's see, Program Files, Super Slicer. Super Slicer is sort of. There we are. It's a fork of Prusa Slicer that adds a ton of features, and it is just much more conducive to working with a multi-extruder printer than Prusa Slicer. Renee, who helped out a few weeks ago. There we go. Renee, who helped out a few weeks ago, recommended it, and it has been playing real nice. Oh, there's a new version available. Maybe we'll pick that up later. Okay, so we're going to do PLA with turbofans. We want to print this using, let's say, the gray filament, so we want to use extruder number 2. So let's just make sure that actually works. Tool, extruder 2. There we go. Yeah, I want to use the crappy filament. 2 perimeters, 0.2 millimeter layers. Let's add some vertical. Let's add some top and bottom layers. Brim should always be on. It sure is. We don't need any support material here. And I think that should be good. Getting much... No. All right, half an hour. Excellent. Not only am I getting better at using... the software and working with the printer... Like, not only am I getting better at using the printer, but the printer itself is also... I've been improving it over time, so it's... The whole system is working better and better. So it's getting to the point where when I start a job to run on the tool changer, I'm actually fairly confident it's going to work. No? Yeah. I'm actually pretty confident it's going to run. Mindspeed200 asks, are those pipes on the left for water cooling? They sure are. The leftmost extruder is... let's see, the leftmost extruder is liquid cooled. Yeah, look at that calibrating. You can hear that fan turning on? It's because I changed the G code, so now it starts the preheat before it picks up the tool. That was much harder than it sounded. Yeah. Marty Gem 717 asks, should you model a flat in the center hole so the sweet, I think you mean set screw, is always indexed to the shaft flat? I could, but it is possible I'm going to have to drill the hole out. And I'm also probably not going to see... So, first, I'm probably not going to see the flat. I'm just going to be like, why isn't this going in? The second thing is that it's going to create a convex hole, right? Like it's going to create, it'd have the round here and then a flat, and this part is going to round off, and it's not going to fit very, very tightly. Okay, so it's picked up the tool, and now it's waiting for the temperature to get back, or now it's waiting for the temperature to reach 215 degrees. You notice that this is heating up really fast. It's because I put socks on all of the, the heater blocks there, and I partially reran PID. It's overshooting because I think I had the fan turned up too high. I've figured that I've since all that trouble, half of that trouble we were having with not being able to print, like with not being able to lay down the third layer, was caused by the fan being on too far. It's far too strong. So yeah. Ah, there we go. Oh, that's the wrong button. Yeah, let's print. I have to. One thing that I've been meaning to write in that I haven't been able to is like a priming line. Have it like just squirt out a thick. Have it squirt out a thick line to clear the nozzle and wipe any crap off. The thing I should really do is I got to fix the priming scripts, and then I have to fix the brush. So this has a little. So you see the bristle brush on it? You might not. It's to the left. It's to the right. Yeah. So it has this brush, and there's a script to drag the head across the brush to wipe off the booger. Because if you're doing multi-extruder prints, the extruders are going to ooze while they're still on the rack. While I was getting this set up on stream, actually, I think, while I was getting this set up, I crashed a nozzle into the brush, and it ruined everything. So I've got to redo that. Yeah, it's going to pick up some sounds. If it's too loud, I'll change the. Yeah, if it's too loud, then I'll mess around with the audio. The omnidirectional mic is going to pick up a lot of noise. Improving our sound, improving our AV to improving our stream AV is supposed to be there. Ian Ross asks, is supposed to be teardrop shaped. Yes, the tear. Yeah, I assume you're asking about where is it? Open up Fusion. You're asking about this right here. Yes, it's supposed to be teardrop shaped. If it were circular, there would be an overhang here, and that would sag during printing, possibly block the hole. By adding in these the teardrop shape, it is always going to. It can print a 45-degree overhang. Don't worry, I'm keeping an eye on it from here. I can get a profile view. Let's see. Yeah, it looks all right. Oh, our humidity levels. Oh no, humidity level rose. The dehumidifier must have run out. Must have filled up. Yeah. So so it looks like it's printing all right. It's going to take about a half hour to print this. So yeah, let's so we can. So while it's printing, let's turn our attention back here and run off the top half. So let's hide our sketches here. Yeah, let's hide our sketches. So we're going to make a new sketch on top, and project the whole shebang. And how do we want to do this? I'm thinking that we'll have like a bit of a cylinder come out, and maybe like we'll add in some. I'm thinking that like we'll have a little bit, and then we'll dome the top so it's less. Just so it doesn't have sharp edges, it doesn't draw attention to itself, and we'll add ridges in the side. We'll add ridges in the side to let you grab onto it. I think that's the way to go. So there's nothing else to draw here, actually. Instead, we are going to sweep this geometry. So, we're gonna sweep this. So we're gonna need a center line. I think it can be a center line. All right. So this thing has to be. So we need 10 millimeters. So let's see, it's about this far. Yeah, 10 millimeters for the magnets, and then like, what do you think? We could just, yeah, we can go at 12 millimeters. We'll round the corner. I think. Yeah, let's just draw an arc. We're gonna take it in here. So this we want to be collinear with this. Let's see. We want all these to be tangent. How big do we want? How big do we want this though? That's the question. We could do it at 2. I think that's fine. Or more. Or yeah. We also get an ellipse section. I think this will be fine. Yeah, I think this will work. Okay, so down here we want to add some. Like some ridges. Ridges for her pleasure. We want to add some ridges to. Oh man, words. Damn it, I'm friggin' tired. It's for people to grab onto when they want to yank it off. So let's actually a pattern would probably be better for this. Yeah, I think a pattern would be the way to go. So let's put this here. Probably want these to be what, like, I think 60 degrees. Yeah, I think so. I think 60 degrees is the way to go. So yeah, we want. Let's see. Yeah, I'm just trying to center this. You know, let's delete all this and start over in a different place. Okay, so we want a line coming out at center, and these are going to be like the serration type deals, so we'll call that 60 degrees. How deep do we want this? Maybe like at 1.2 millimeters. It doesn't have to be a lot. We're just adding a little like surface area to it. Yeah, there we go. Let's space this off the ground. Yeah, space is off the ground, and let's and then we're just going to make a rectangular pattern of this. And we're going to go this away. How do we want to do this? This should probably be all right. I think I might have. It might be 1.2 might be too much. Maybe something smaller, 0.6. And I'll add more of them. I think that's the way to go. Come on. Yep. I think this is the way to go. So let's finish the sketch. Actually, I haven't saved, so we want to save this in the project I made for her, Pauline's mandala. Let's see. We'll call this one the disc retainer. Alrighty. So we got this guy here, and let's revolve it. I said sweep, I meant revolve. So we're going to make a new body. Very nice. Alright, so now we have the top section. It's got some ridges. Let's hide the bottom to make it easier to edit this, and then let's extrude these guys. 10 millimeters. Alright. So I just want to make sure that there's not... just want to make sure that there's still, like, room. So this part, we have to be careful. Jeez. Alright, so this part here, we have to be careful that this looks good. We've got 2 millimeters here. I think this should be alright. This has to look good because it's going to be visible. Maybe we want to make this even... alright, let's go back in here. Nope. Yeah, I think I want to make the top even more rounded then. Let's see, how do we want to do that? I think we'll do the miter. We should do the miter after the fact. I think I'm gonna get rid of this. So let's have this guy and this guy be coincident. What? Oh. And let's change this to 12 millimeters. There we go. All right. So let's fillet it. All right. Let's change this to wireframe so we can see what the heck is going on here. I think that looks all right. Let's just confirm that there's going to be enough plastic. There's a millimeter, not a lot. So I'm just going to change this back down to 6. I think that looks pretty solid. This looks all right. We got some ridges to grab onto. Actually, we got some ridges to grab onto. I think I'd rather just make. I think I'd just rather have fewer of them. Yeah. Instead of minus 3.5, let's call it minus 1.5, and instead of 6, we want 3. Oh, the extent. All right. Wait, why did that? What happened here? Minus 3. There we go. So now we got a little surface area to grab onto, and this I think will print out of TPU. Let's actually extrude this. I just realized we're going to need more. Yeah, I think we're going to make this bigger. I'm going to get these in for 12. The reason is these have to be flush or deeper because they don't have a lot of friction, right? They're metal. So if we want to make this thing, if we want this thing to be have some friction to it and force carry the disc with it, we have to make sure that they're set back a little. So that's going to punch holes in the top, which we don't want. So we're just going to have to edit this. Bring it up to 14 millimeters. That should be fine. All right, excellent. So in order to print this guy, we're going to run some TPU. Unfortunately, there's nothing. Unfortunately, I can't show that because it has to take place in the 3D printer closet. So yeah. Pigeon King says, is there a way to template a pattern like that to reuse in other projects? Fusion 360 is not really designed for that. It's actually very hard to reuse stuff across projects. Yeah. So, yeah, we've got all the pieces. We've got this bottom part that we're printing out of plastic. That will space the piece of art away from the device. It's gonna have some magnets in it. On top, this part is going to be made of TPU, and that's just going to stick on top with a magnet. And stick on top with magnets, and that'll hold it in place. Ted asked, "Will TPU take paint? What if the artist doesn't want it to be that visible?" Well, I'll print it in a color that ours is going to be printed in black because that's just the color of TPU I have. But I think if it's in white, it's not going to make a difference. Unfortunately, the problem, unfortunately, we have to make a concession somewhere. Like, if we were to just we can't drill in through the side, right? We can't drill in through the side. We can't. I don't think it's a smart idea to have a set screw. We can't put a screw in the front here. I can't make something that I can't thread it internally. I can't have anything that threads around it because the drill has to be a certain size. So covering up let's see, 14 millimeters is this much. So this looks big on my screen, but this whole thing is only this tall. It's going to be let's see. How wide did I make this? I think it's 30. Yeah. So the whole thing is only going to be this wide and this tall. So it is actually much smaller. J3 asks, is the magnet going to hold the weight of the disc, or there will be a center shaft hole? Oh, I mean, this is all going on the shaft of the motor. So this is what's actually holding the weight, right? This is what's actually holding the weight. The purpose of this thing here is just to apply friction to it, so the shaft can actually drive it. And also, just to give it a little piece of extra insurance so it doesn't fall off accidentally, while still being able to take off while still being able to take it off to access the battery. Yeah. IDSK says, why don't you just put some grippy plastic threads in there? I don't understand. I can't, yeah, so we've got so this is the piece of art, or this is like my mock-up, my stand-in for the piece of art. And it's basically it's a 1 meter, 3 foot plastic disc with 5 millimeter hole in the middle. And I can't make the hole any bigger because she already made all the art pieces. So, yeah. Let's take a look at our printer. Let's see. Oh, I keep forgetting. Let's see. Well, there's not much to see. Maybe I actually set the camera up too high. This is really awkward. Yeah, I think I'm going to move this printer onto the floor. Yeah, it's covering the good stuff. Damn. Yeah. Oh crap! Did I put ads on? Oh Jesus! I never put the a sec. Oh crap! That explains why our numbers are being so weird. I put video ads on. There shouldn't be any pre-roll ads. Dang. Casper Walchuk says, will magnets be able to hold that up and all the stuff on it? Well, we're gonna find out. Yeah, we're gonna find out. If it doesn't, then things are gonna have to get a little more complicated. Because I think if it doesn't work, then we'll probably make a cap that you mount with a screw, and then there will be another third magnetic plate that will another third magnetic plate that will cover the screw. So we'll see if this works. Sorry for everyone who had to watch ads before the stream. I just switched them off. I don't like pre-roll ads in front of streams. So I turn them off. Yeah, I could show you one right now if I wanted to. There's an ad break button. Here is. All right, let's think. We could do a little science experiment. What do you say we? What do you think? Folks want to try a little science experiment here. Basically, in my every filament video, I said it's really hard to print TPU through a Bowden. So I have this Anycubic Viper from another stream which has a Bowden. Do you want to see what happens when we try to? Want to see what happens when we try to print TPU through it? Alternately, we can just print. Let's just do it in the other. Let's do it in the 3D printer closet. All right. So we're going to need to temporarily move this camera out of the way. We're going to switch to the overhead camera for now. I'm going to temporarily move the camera out of the way and avoid ripping, crashing it into the ceiling fan. Or why is this moving? Oh, it's vibrating because it's on the thing it's on the table with the printer. Ah, crap. Oh, it's sending in enough vibrations to throw off the camera. Ah, booty. All right. Well, that's a bit disappointing. Yeah, as much as I love to do like dry runs and rehearsals of everything, there really isn't enough time. So here, let's just see if we can. I can't. The wire's not long enough. It's hooked on the flag. All right. So let's see. Can we see from there? Not really. Well, I tried. Crap in a hat. Not a lot of options here. I guess we could set up on the table, and then just reuse one of the other cameras. Oh man. Okay, let's think. I suppose we can't use that camera either because we need it to look at the other printer. This is way too much to do. I'm so friggin' tired. I'm gonna be up until 6 o'clock today finishing the episode. Hopefully it gets approved sometime soon. Let's see. Brooke says, yes, I missed a Blade of Kittens super chat. Oh no! I can't see anything with the friggin' camera in the way. This is the worst stream. Blade of Kitten, thank you so much for the super chat. I really appreciate it. I'm terribly sorry for missing it, and I don't think you added a comment, but I really appreciate it. Thank you so much. There we go. Yes, we do. We actually don't have enough cameras. The setup we have. I'm planning on. It's going to take a bit of work. But I'm actually planning on adding 3 more cameras to this. At least 3 more cameras to the setup. We're going to put one camera. We're going to have one camera for the 3D printer. We're going to have another one pointed at the second workbench, so we can get shots of like cleaning up resin prints and other such stuff. And probably we really need a ceiling cam. We need something to keep focus on me as I move around the space. So get some tape or string and hang it from the ceiling. I'd love to have like a gantry. I'd love to have like a camera on a gantry. Hang on one sec. I'm just gonna refill my Green Thunder. All right, we're running in circles again. People want progress. Let's give them what they want. I'm going to go into... if you want progress, I'm going to give them what they want. I'm going to go into the back for about 1 minute while I set up the printer. So I think the best I can do is point the face cam over there. The mic's already in position, and let's take a look at our... let's take a look and grab some questions. Ted Milker says, so many cameras and they're all useless right now. You know what? It takes time to, you don't just buy a piece of equipment and throw it there. You need it takes time to practice and set it up. And I am barely keeping my head above water here. So, look, I take responsibility for it. Brooke says, Green Thunder. So I admit the camera setup kind of sucks today. It's a work in progress. I didn't even know we were going to do this stream until last night. I was originally going to do something involving resin, but I realized that I couldn't buy the parts I needed. So, yeah. Anyways, let's move this camera out of the way. And, actually, now I'm thinking about it, it's probably a lot more interesting, instead of watching my back as I shuffle around, it's probably more interesting to watch the printer as it prints. Yeah, get your printer print ASMR. There we go. Let me get this even higher. Can you take me higher to the printer? Yeah. All right. Let's get this done. All right. So we're going to be printing it on this machine. We're going to be printing on this machine here, and currently got PLA loaded into it. So we're going to have to unload that, run through some purge filament, and then we're going to unload that, run some purge filament, and then load up our TPU. Now. TPU, you can print TPU on a PEI steel sheet, but it'll stick to it permanently. So this is going to need a thick layer of glue. Extra thick! Let's see. Enigma says you could use your phone for an emergency camera using something like Droid Cam. It's a little impractical because it's going to be wired, right? It's a little impractical because it's going to be a wired camera. And in order to make it useful, where are all my glue sticks? Do I have to order more? Oh, crap. I'm almost out of glue. I didn't even realize it. In order to make it worthwhile, it needs to be on a pretty long cord. I gotta use a USB cable extension, and I find that the cable extension is very easy to pull out by accident. So, I only pull out on purpose, yeah. So I gotta be careful with that. I decided for now it's just not worth it. But we might bring the phone cam back later. Because the phone is a really high resolution. We can actually get 4K footage off of that. Alright, switch the light on. Let's unload our PLA. Yeah, unload our PLA. I gotta edit the G-code for this so it plays a tune. How are we doing over here? Oh, this is looking good. The printer's not quite dialed in yet. Still a lot of boogers. I think it's over extruding. I think I made a. I think. So, I calibrated the extrusion multiplier by you extrude 100 millimeters of filament. You measure how much actually came out. So I calibrated that, but then it wasn't printing properly. So I thought it was that. Turns out I think it was the fans. It was these crazy hot cooling fans. So I think I should revisit that. Yeah, calibrating your extrusion, your E-steps, is really, really easy. It only takes about 5 minutes, and it can massively improve your print quality permanently. So if you've never done it, you totally should. Yeah. Is everyone talking about hairstyle? Awesome. Enigma says Droid Cam has wireless support. I don't really trust wireless cameras. I've had bad luck so far. I also don't have an Android. Geez. We also don't have a function. I don't have a functional Android device. Last time I broke my phone, I replaced it with an iPhone. Alright, so let's get the filament out of here. You're out of here! This is, this is something new. This is a refillable spool from Fusion Filament. I bought a few of their so like when they switch colors, right? The filament is kind of unsellable for a while because it's a bunch of colors mixed together. So they sell that on the cheap. So I've been using that for my test. Just prints where the color doesn't matter. So that's what this is. Kind of cool. Alrighty, so let's get this out of here. Right, we need purge filament. I have to order more of this because I'm going to be using a lot of it as I print like 100 materials. Because the next every filament episode is going to be off the charts. So let's run through here. The reason why we're using purge filament is because PLA melts at 215 Celsius, but TPU melts at a much higher temperature. I think it's closer to 250. And if there's still PLA left in there, it's going to burn. That's definitely not what we want. We don't want anything burning. So this filament is stable at a whole range of different temperatures. One thing I don't know is what its maximum temperature is, because we're certainly going to hit it when we're printing these high temperature filaments. Let's load again. Yeah, because we're definitely going to hit it when we're printing high temperature filaments. So yeah. Hopefully we don't burn the filament. That's designed to make sure you don't burn any filament. That would be a little on the embarrassing side. Come on. Go through. Yes. Unload the filament. Alright. So next step is to preheat for flex. Prints at 240, or at least they want the printer primed at 240. So yeah, we'll heat that up. And where is a flexible filament? I know I have a little bit left on a spool. Here it is. Flexible filament. This is 98 Shore. So it's pretty stiff. It's not like floppy. It is bendable, but it's It is bendable, but it's still fairly rigid. Sort of like a skateboard wheel, you know? This stuff should be pretty easy to print, and it should give us a higher surface energy, right? Like a higher, oh jeez. It fell off my little rack here. It should give us a higher amount of friction to drive the disc. So let's, we need an Allen key because we have to release all the tension from the extruder. You don't want to pinch TPU very hard. You want the bare minimum amount of tension on your extruder. So I'm just loosening the drive gear. At some point I gotta get like a chest cam or something. So let's load this. It should go fine. If it crackles and pops, we got a problem. But it should be too waterlogged. Let's see. Go, go, go. After this, we got to empty out the dehumidifier because it is full and today is a little on the humid side. Alright, so let's run a bunch of TPU through here to clear out the purge filament, and then let's take this back to the bench. I'm going to run a little bit more. I really like TPU. I think it's underrated as a printing material. Even for stuff that you wouldn't think should be TPU. Like one of the Nerfers, like they have a Nerf blaster that does shotgun shells, right? Like it releases shells as you fire. And you printed those out of TPU. You wouldn't think of using TPU for something solid like that. But it makes them indestructible. Like if they fall on the ground and someone steps on them, they don't get crushed. Pretty neat. All right. So, look at this. See that red? See that red line right there on the top? This thing is full. All of this is water that would have ended up inside our filament if the dehumidifier wasn't there. So yeah, dump that down the bathtub. All right. Oh. If we're going to dehumidify, I should have the door closed. We're going to want to watch it as the print begins. We're going to want to watch it as the print starts. Oh, hey, look at that. Before we go and peel that off, let's turn our attention back to... before we finish that off, let's turn our attention back here and let's start this thing printing. Pardon me. Alrighty, so we're going to go to Tools, Make, Print. We're not sending this to Super Slicer. We are sending this to Prusa Slicer. I should really have like a list of all these shortcuts. Prusa Slicer. There we go. Send it. I think our overhang will work. Here's a question. We need support material. Common misconception is that TPU doesn't support well. It actually does really well on supports. Yeah, I see. So I'm thinking we'll just support this. Okay, so we're going to use... Alright, so we're doing this in the Squire of Squirt. It's got a 0.4 millimeter nozzle. I don't want to change it right now. TPU. Let's use our TPU. I got a profile for that. Alright, print settings. We want 0.2 millimeter layers. You don't want to... I think we're going to go 0.15. You don't want to lay down TPU very fast because it tends to get weird if you try to print it too fast. So we're going to do supports on the build plate. Let's just confirm. All right, so it doesn't think it needs supports at all, and I'm inclined to agree. Let's send it to the Sultan of Squirt. Unlike the other, I need to set this up for the tool changer, but we can send this directly to Octoprint. Boom, Squire of Squirt. Let's make sure it made it there safely. Oh no, everyone knows the IP address. So this should be running.
Matiek6, pardon if I slaughtered your name, asked, what do you use to move around the 3D viewer so smoothly? That's a space mouse. I use this three-dimensional navigation device that was bought for me by one of our viewers on stream, actually. And yeah, it makes it a lot easier. It makes it a lot easier on the eyes than yeah, like this is a lot easier on the eyes than like this. Yeah, it's pretty neat. Would I recommend it to someone who isn't streaming? I don't think so. Yeah. So, all right, let's pry this thing off and take a look. Where's my palette knife? All right. Technical difficulty. Got to get under this wire, over this leg, and I can't block the frame. Come on. Maybe I had this leveled a little too close. It's definitely over extruding. We'll give the extrusion multiplier a look. I'll put that on the old to-do list. All right. Okay. So let's rearrange the furniture here. Let's not give everyone. No one wants to see my crotch. All right, here we go. Looks all right. So let's peel off the brim. Not going to worry about trimming it. There's a pretty high chance that we're going to throw this straight in the trash. So yeah. All right. Let's check that it fits the motor. Yeah, it's not fitting the motor. How wide did this actually come out? Let's see. So the shaft actually came out to 4.8, and it should have been. Came out to 4.8, and it should have been 5. But that's all right. We're planning on drilling it out anyways. A little hard for me to grab my drill right now, though. Man, my throat is really acting up. Where did I put the power drill? I thought I was using it just the other day. Here it is on the other side of the computer. All right, so let's drill this out. 5 millimeters is roughly a 1/4 inch, right? 1/4 inch. 1/4 inch might be a little wide. 15/64. 7/32. That'll work. 7/32. All right, let's drill that out. Let's see how that fits. So yeah, this is roughly the process I use when I'm building stuff for clients. Because remember, my goal, like, if life gets in the way, right? That doesn't release me from my deadline. So I want to make sure that I have something to show as often as possible. And yeah, we also have to test our assumptions. The temptation is always to like do all the engineering and then start working on it, because no one likes to see that the thing they've been working on, like, no one likes to work. You know, you build up a head of steam, and then you see that you have to go back. But you know, it's the nature of the game. You got to test as often as possible. All right, so that's much smoother. So let's try to jam the nut in there. I wish this was focusing. Unfortunately, this is going to be it for this nut. There's no possible way we're going to be able to pull it back out. So yeah, so this doesn't even come close to fitting. Yeah, this doesn't even. It's not even close. It should be. What did we say before? It should be 2 millimeters, but it's actually 1.5. Yikes. So yeah. So let's
So what I'm doing here is, on the other screen, I'm just editing the dimensions. Just to compensate for... Yeah, this printer's not as well... this printer's not as well tuned as the Prusa's, so I have to take that into consideration. 5.5. Right, and we hollowed this out. 5.5. All right, I think that'll work. Okay. Let's see how the magnets fit. I'm going to be careful here because I don't want the magnets to be stuck forever. So we made these loose, and sure enough, they are loose. Maybe even a little too loose. Let's see. A little on the awkward side, trying to hold this magnet in place. It's about 0.5 millimeters of clearance. What's your clearance, Clarence? So, let's see. So yeah, I'm just adjusting these as I go. This is 4.5. Let's call it 4.25. Shrink it down a little bit. Yeah. Juzza's01 says, for inner diameter measurement, use the other end of your caliper. Turn it around. Easily widen the mouth for max diameters. That's what I was doing. Yeah, that's oh, jeez. That's what I was doing. Yeah. That's what this thing is for. Yeah. This is for depth. This is the depth gauge. Alright, so our numbers are a little off. I'm not that worried about the TP... Like, I'm not going to stop the TPU because, I mean, it's stretchy, right? Like, we can... It's okay if it's okay if it's a little too small. We'll be able to jam it on there. In fact, we might even want it to be a little... We might even want it to be a little on the tight side. Let's actually go back there and take a look. I'm going to leave you guys and gals hanging for one sec. All right, it looks perfect. Yeah, TPU. It's pretty rare to get a crappy TPU print. In general, it either works perfectly or it just completely goes nuts, like more or less right away. Okay, so this is got to be a bit wider. Maybe you should call this one 6. Let's switch back over so you folks can see what I'm doing. Call this one 6. Increase the dimensions here by about 0.5 millimeter. Maybe they should even be a bit wider. Maybe this should be 7. Move this in a little bit. It doesn't, yeah, because most of the strength is in this side, not this side. So, yeah, and increase the size of that. Finish the sketch. All right. So yeah, let's run off number 2. Let's run off the second revision. Going to close down Super Slicer. We don't need either of these anymore. We don't need that. Yeah, I actually want to save these. Save our presets. Alright, so let's go back to the Make menu. Let's make this. Let's send it to... We have to go back and reselect. This is really annoying. We got to go back to Super Slicer. There we go. Super Slice. Super Slice that hoe. And we'll run off another one. I could change... Ina says you could change all the holes to different diameters, but then I couldn't use a circular pattern. I have to do it all manually. So we want this on extruder number 2. Let's just make sure everything works. Extruder number 2. I'm actually going to move this down a little bit. We're going to turn the brim off. We don't need the brim because there are no pointy edges that have to be nailed down. And we don't want to hit the same spot over and over again because it'll pull all the glue off. There's no point gluing the entire build plate if we're only using the center of it. So this should work fine. Let's slice it, dice it, export it. Export our G code. This starts 8.3. So let's go back to... There we are. Let's go back to Squirtsephone's control panel. 8.3, that's it. And we are live. I gotta say, Duet Web Control is way more responsive than Octoprint. Octoprint's pretty heavyweight. It's hard to believe that like the entire duet is running on like an ESP32. Yeah, it's pretty sick. Pretty sick. This should move a little faster. Innis3322 says, is the persistent thing to do now make a 3D print hole test jig or change dimensions based on measurement and print the part again? I don't think it's... What's a way of saying it? Like, there are so many factors that affect how the geometry of the print relates to the geometry in the slicer, or in the model. I don't see a lot of value in making like a test, a test stencil. Pardon, unless all of your printers are dialed in exactly the same, and you're making sure, if not to calibrate the, if not calibrated perfectly, calibrated consistently. I think that's kind of on the hard side. Yeah. Joe Gibe says, fluid and mainsail for a clipper are silky smooth and responsive. I am not. No effing way. I came this close to swearing my face off. No effing way am I going to write a set of scripts for this tool-changing 4-extruder printer with 4 different nozzle diameters and all kinds of crap, and write compatibility for Super Slicer or whatever. Again, for Clipper. No way. Like, that's like 25 G-code scripts that would have to be rewritten. I think you should be able to see this a little better. Is anything coming out of there? Oh, right. All right, there is stuff flowing. What you're seeing is the Z-axis homing button, not the nozzle. So if you think it's not printing anything, don't worry. It's fine. It's fine. Everything's fine. We're all fine. I'm going to take a look at the Squire of Squirt. Looks all right. Squire, yeah, that print is going to take a bit longer than the others. It's going to take, how long? Probably an hour and a half. An hour. All right, so that one's going to take an hour. Pretty neat. Valdirk says, skateboarding was added to this year's Olympics. What do you wish was added to the Olympics? I don't really watch sports, so... I don't really watch sports, so I'd want something really controversial that people in America hate. So let's see, what... They already do soccer, but that's... No, it has to be something else. A child beauty pageant. Yeah. Yeah, just something that just turns people off from it. What else? Could play Quidditch. We could do Nerf War, of course. I mean, I can't believe it took me so long to think of that. Yeah, Olympic competitive Nerf Wars. Nerf would make a terrible Olympic sport. One of like the most important parts of the Olympics. The thing that sets it apart from like other all-star tournaments is that the Olympics, everything is standardized, right? Like, if in swimming, like everyone's using the same swim trunks. In the biathlon or like the triathlon, everyone's using the same guns. I think, or if they're not the same, they're made to some crazy level of consistency. And the best part of a Nerf War is that deciding which blaster to use and modding it the way you want it and then getting practice with it, that's the thing. Basically, Nerf Wars start on the workbench. And I think if it was done in a setting that standardizes everything too much, it would just... I mean, it would be an interesting combat sport, right? It would be a lot like paintball, except with less spam. It becomes less of an issue of aggro and more of an issue of positioning. But I think the thing that makes it worth watching and worth participating in would be lost. But, yeah. Yorn04 says, what about photography? What, like competitive ranked photography? How do you do, like, they'd have to, like, run around the Olympic Village, like, taking pictures, and, like, the best pictures win? How'd that even work? Aerorator says Olympic chess, and that's brought up a lot as a joke, but I actually think that would make an excellent Olympic sport.
I wouldn't even... Honestly, I don't even think it's a bad idea to do esports. Like, it would be interesting. Like, I wouldn't add, like, StarCraft as a game. I would add esports as a game, and basically whoever picks the Olympics would be deciding which esport that, you know, which esport is being done. Or, you know, or you can standardize it or something. But, like, I think it's a great Olympic sport because it's a game, because video games are already played worldwide. They're already something that brings the world together, and I think that it fits the spirit of the Olympics like perfectly. Yeah, Olympic chess boxing. That's what we need. Yeah, we need chess boxing. That's when you fight around in the ring, and then you play chess, and then you fight around in the ring, and then you play chess. You just go back and forth, doing that until you're either knocked out. You put them in check, or you run out of time on either the chess clock or the boxing timer. I forget the thing. Yeah. Cohen Carell. He's responding to someone else. Drone racing, says Nicholas Marshall. Olympic drone racing. Yes. That would be pretty neat, actually. Although I think it would suffer from the same problems as like you can't really do Olympic like car racing because it's not practical to standardize it to a level where every country can compete. And yeah, it's an interesting question though. Definitely, yeah, that's kind of neat. I never really thought of this. I think I depending on different games play out differently, but I think esports, I think the popular esports, like, you know, CSGO, StarCraft, even to an extent Fortnite, yeah, absolutely, now I'm thinking about it. Definitely Fortnite. There are sports, like, there are physical challenges. It's not just enough to have good reflexes and to have to have an understanding of the game system is to have a lot of practice and good strategy. Like, you physically need to manipulate the system to a high degree. And yeah, competitive fighting games would be terrible. Like, fighting games in the Olympics would be awful. Like, people would die. People would literally die. That could be pretty neat. Prince K says, make a new Nerf video. Also love the videos and streams. I don't think we're going to make we're not going to make a Nerf video for a while because I just have a number of videos coming out on different topics. It just hasn't been able to fit into the schedule. Yeah. I think Fortnite's a cool ass esport. Like, just players have so many options of things they can do, and being able to build stuff while in combat is such a neat skill that I don't see tested in very many other games. I think that would be pretty neat. Yeah, I think that would be pretty neat. So yeah, not that much to do right now. We wait for these prints to finish up. So yeah, I guess we should have also tested the other dimensions. Oh, this is fine. Yeah, the Z dimensions tend to be good on. Like, it's really hard to screw up if you screw up your Z dimensions, something has gone deeply wrong. Yeah, something has gone all the way wrong. I just whacked this against my hand to knock the screw out, and the screw went flying off into the sunset, Team Rocket style. Hey, Billy's in chat. How's it going, Billy? How is life? How's things? Remember when Valorant was supposed to replace Counter-Strike? Pepperidge Farm remembers. Oh man, have I ever done the competitive Smash rant? Have I ever done the competitive Smash rant on the channel? Because that's gonna lose me every person's respect. I have the hottest take on Smash Brothers. Competitive. Yeah, Billy's here. All right. I'm gonna lay it on you.
I'm going to lay it on you because you're cool folks who've stuck around so long for the stream. I think competitive Super Smash Brothers should have a random stage and random items. That's it. Like, I think three stock is fine. Maybe if you might even want to increase it to, you might even want to change it to like 2 stock on 3 stages or something like that. But I strongly believe that Smash Brothers is designed and intended and balanced to be played with a variety of stages and items. I don't think it's enough to just get good with your character. I think you have to get good with your character no matter what stage you're playing, no matter what item gets thrown at you. Like, yeah. There some of the characters that players think are like the worst garbage. Like, some of the characters that some players think are the worst garbage. Like, most notorious, I think, is Rob from Brawl. Rob is like in competitive. Rob is like trash tier because he doesn't move very quickly and his attacks are very predictable. But if you're playing on a if you're playing on a level with like multiple, with like multiple levels, maybe even moving hazards, random items, Rob suddenly gets really, really good because he can attack through. Like, he's one of the best characters at attacking through floors, and he has 2 different ways to interact with items from a distance. So yeah, that's the hot take. Try it. Like, if you're playing with, like, you're playing with somebody who's competitive, right? Don't have them handicap themselves. Just put it on just default items, random stages, and play try playing like 1 or 2 stock best of 5. And you'll see that the math changes significantly. Yeah. Marty Chan makes an excellent point. The worst garbage seems to be balanced with Smash Ball. I think you can make a strong argument that the Smash Ball should be disabled. Not only is the Smash not balanced, they're not balanced very well against the characters, except for Meta Knight. Meta Knight was clearly balanced in a meta that you like internally. In Nintendo, presumably. Meta Knight was clearly balanced in a Smash Ball heavy meta. But you can make the point that you can disable the Smash Ball. On top of that, some characters just can't practically reach the Smash Ball, and some others can body it from all the way across the stage. But, yeah. That's my hot take. Final Destination is, like, characters that can move side to side easily and can handle edges well are just really favored on Final Destination, and characters that have moves that interact with items, like Mario, Rob, Wario's another good one. They just, like, those attacks are just switched, like, the Ness and Lucas, like, a big part of their kit is just switched off. Yeah, there you go, that's the hot take. A lot less controversy than I was expecting. I thought people would freak out. I think the different stages, in my opinion, is like the defining part of Smash. Think of it. In what other fighting games are the stages like? In what other fighting games like are the stages different? Right? Like, sure, they might look different, but they're all the same. They're just a flat surface with a coat of paint on them. All right, sure, and like the new Guilty Gear and Street Fighter and a few Dead or Alive games, like, you can move to, you do a certain move and you can jump to another part of the stage, but it's all the same crap. Literally, the only fighting games I can think of where the stage matters are Soul Calibur and Smash Brothers, and in Smash Brothers, it's always switched off. Anyways, let's get back to building stuff. Sailor1496 says, "You're one of my favorite creators, and how genuine and creative you are." Ah, thank you very much. I appreciate the kind words, and I am quite flattered, and I very much appreciate the support. Yeah. Cordy says, "I'm freaked out." I appreciate the super chat support a lot. So let's see. We're about halfway through printing the bottom section. Let's just take a quick look back in the closet. Right. the TPU is printing perfectly. Yeah, I'm just killing time right now until at least one of these things finishes. I guess we could, like, it's already 4:30. We could jump into modeling the. Yeah, we could jump into modeling the frame for this, but we're not going to get tremendously far. So yeah. So yeah, probably like kill a little time. I guess we could. Here, let's jump back to Fusion. So I've already partially modeled this, and when I say that, I mean I put about 15 drunken minutes into copying the dimensions down. So this is the rough idea. Where's my space mouse at? Yeah. So this is the rough idea of what we're building right here. So this guy right here is a. This is right here is where the board is going to go. In the middle, so the weight is balanced, we have the stepper, and then over here we have a pocket to hold our USB battery. And yeah, we got to change a few of the. Sure, it's I realize. So I've been notified that it's out of stock on Amazon, and that's almost certainly because I bought 23 of them. So yeah. Marty Jam 717 says, so are the XY axis traverse distances governed by extrusion rate, or is it more so layer thickness and fill? XY traverse distances. You mean like how far the nozzle has to move in total, or like how much filament, how much extra, like how inaccurate the dimensions are. Yeah. So this is a big hoss. Yeah, this is a big boy here. It's a big chungarino. This thing is, I can't even measure it. It's over 150 millimeters long, so this thing is going to have to be at least 80, maybe 90. Let's see. So this is 90. That would come up on here. Let's see. 90 would come up to about here. So it might be a little top heavy. Might be teetering a little bit. I think bringing it up to 100 would make me feel a lot more relaxed. There we go. All right. So let's see. We've got our motor mounted in the middle. Over here, let's copy our dimensions down from Eagle. So let's go back to Eagle. No. Fusion mandala. Why can't I drag this over the other window? Oh, because I have a power drill blocking my mouse. That'll do it. That'll do it. All right. So I just tried to use the space mouse. So I like to take dimensions of my boards and put them on the dimension layer, or the document or reference layer. Measures. I guess not. All right. So let's do that. Let's put these on the. Where is it here? Reference layer. So we're gonna go from here to here. So we got 51 millimeters here, and we've got 44 millimeters here, and we want to add. I think I'll add a full millimeter. All right. We also. Oh, of course. We also. Oh, geez. How do we do this here? We also want to measure from hole to hole, but it's not letting me. Yeah. How are we gonna do this? Is even gonna. I don't think it's even going to let us. Yeah, I think we're going to have to hide the. We're gonna have to hide the drill. We're gonna have to hide the hole. Holes. Yeah, we have to hide the hole and do it manually. Oh, it's still not working. Damn it! Oh, because we still have the stop. We still have the stop mask visible. There we go. Is this going to work now? Nope, it's still not going to work. Because we have... so we have to hide everything. We got to get the keep out of here, get the restrict out of here. I hope it works now. No. Is it just going to let me... I can't just draw arbitrary... Yep, there we go. There we go. Alright. So these are 38 apart. And... let's see. So we want vertical. These screws are 45 apart. Okay, good. So we need to leave. All right. So let's. I'm not going to try to remember anything because I am very tired. So let's put this over here. Oh, that didn't work. Yeah. Geez. Yeah, this isn't playing well with our window manager. How do I do this? I have to hold shift. No, half the screen, you stupid software. Not the whole screen. Why isn't it going to half this? Why? I'm so confused. Is it just not letting me make the... It's not letting me make the window any smaller. Alright, so it looks like we're just going to have to tab back and forth. So this... Not 51, we want this to be 53. This one, we want to be... where did I put the dimension for this? Oh, there it is. 44. We don't want 44, we want 46. Let's see, what's setting the dimensions here? Oh, nothing. Good. 5 millimeters over here. And, yeah, I just want to make sure the walls are thick enough. Heck! Yeah. I don't know exactly where to place this in the Z. We'll figure that out later. Yeah. Yeah. Never put off till tomorrow what you can put off forever. So I think I spaced the holes. I think I spaced the holes uniformly. Yeah, I did. I definitely spaced the holes uniformly. All right, so we should just be able to draw a center rectangle that is concentric with this rectangle. I keep forgetting which way is up and which way is down. And, right, we want that rectangle to be 45 by 38. Alright, so 38, 45. So here's a question. How do we want to mount the board? Do we want to just have the screws bite direct? Do we want to just use like self-tapping screws or something and have it bite directly into the plastic? Or do we want to use fancy pants threaded inserts? I think we just want to drill some screws straight into the. I think we just want to drill some. Yeah, I'm going to drill some holes straight into the plastic. So we'll use self-tapping screws. Right. So how big are the holes on my board? I guess I should have. I maybe should have planned this first. Alright. Make this bigger so I can see what the hell is going on here. Drills and holes. Alright, so let's take a look at the properties here. This is a 3 millimeter drill. So we can use a self-tapping screw up to 3 millimeters. So let's see. I might already have one. I don't necessarily, like when I'm using parts from my stock, so yeah, something to keep in mind is when I'm using parts from my given, I don't necessarily have enough. But I'm going to need to order more anyways, right? Because I'm going to be hitting my supply so hard. So, might as well use something I already have so that I can get a head start, self-tapping, for a 5 millimeter head. Outer diameter is, or major diameter is 2.5. I think this is perfect. But so we might as well use something we already have to tide us over while we wait. Remember, speed kills. You gotta be fast. And especially because I'm on YouTube, I can't let this project drag on because I'm on such a tight schedule, such a tight deadline that I can't spend any longer than I need to on this. But that said, like, you know, we gotta be careful to keep our engineering has to be top quality. We don't get a pass just because we're in a hurry, or just because I'm doing YouTube doesn't allow me to underdeliver for a client. So the minor diameter of this is 1.8 millimeters. I am going to try 2. This might be too small. But really, we have a lot of leeway on the dimensions of these. The dimensions of these holes. As long as the plastic doesn't split, we're fine. Yeah, then we're A-okay. Ashley Gittins says, model split mounting pins so the board just snaps on. I don't think that's a good idea. I don't like modeling tabs because either the tabs are on the tabs are perpendicular to the z-axis, so they have a weak point, or the rest of your model is perpendicular to the z-axis, so it has a weak point. So it's never a good. I don't know. I don't think it's really worth it. I think you're better off just maybe adding pins and gluing the model together. If you really want to avoid fasteners. So so let's see. So we've got our board. We've got our board here. We've got our So we got our board here. I'm just thinking if we want to import our drawing. Let's see if it lets us. Let's see if it lets us open up the Eagle file and throw it in. Is that going to let us do this? Drive? I haven't really used the circuit board stuff within Fusion 360. Like, I know it's compatible, but I don't know how to combine the two. I'm wondering if it makes more sense just to take a screenshot. I think that'll do it. Yeah, let's take a screenshot. So yeah, I'm gonna take a screenshot. All right. Oh, I should probably use the snipping tool. I'm gonna use snip and sketch. Yeah, there we go. So we're going to wait. No. Wait. Why did it stop? How do I pick what I want to snip? I don't want to do the entire window. I just want to do a part of the window. Let's see. There we go. All right. And we're going to save this to somewhere. Let's call it our downloads folder. All right. Let's get that out of here. We'll go into Fusion. We will insert a canvas from my computer. Let's open up the thing we just. Let's see. Why didn't it work? There we go. All right. Put it there. All right, and let's open up. Full screen that. Let's open up this and let's calibrate it. So we already know that. Actually, I don't think we really need to calibrate. I think we just need a rough idea. Basically, I definitely want to turn this 180 degrees though. Yeah, this is what it's going to look like. All right? Yeah, it's going to go on this way. There we are. Okay. The reason I'm doing this is let's see. So we can make sure that the screw here doesn't collide with this. We got to figure out how we're going to put in the USB cable. Let's see. So this is the USB cable that came with it. So we can put this. So let's see. We can leave a recess for this, and then just possibly leave a recess for this and just route it out the top so we can plug it in over here. There should be enough. There should be enough room. We also need to leave. We also need to put a slot in here so we can get the motor wires in there as well. However we slice it, these are too close together. So what is dictating it? Is this a pattern? What's going on? What's going on? Let's bring this closer to 20. That should be good enough. Okay, awesome. Cool. This is just getting in the way now. All right. Okay. So yeah, we want to add a relief for this. We're gonna model this for this specific USB cable because we know that it comes with every power bank. We're gonna get some. We'll buy some bulk USB cables to charge all these things later, or even a USB-C charger. All right. So yeah, so we want to leave. Let's call this 12. All right, so let's see. So we're still editing a sketch. That's good. All right. We want to. So we're going to draw a line. Let's actually straighten this out. I still have so much trouble controlling this, and I don't know why. It's like I always want to move it in the wrong direction. All right. So we're building a line. We're building a construction line. We're starting in the middle of our USB port. We're going straight up. Doesn't matter how far at this point. All right. So we're going to do a rectangle. No, we don't want that. All right. We're going to make a rectangle. We're going to get its center point. We're going to make sure that center point is coincident with... Oh, geez. Nope. Hang on a sec. All right. This dot right here needs to be fixed. Like the next dog we get. Come on. These should be coincident. Oh, looks like our 3D print is done. All right. Looks like our new revision is done. Let's finish this up while that cools down. I wouldn't be surprised if our TPU part is done as well. All right. 12 millimeters here. This is getting a little slow, so let's save. Sometimes it gets slow before it crashes. You know, the calm before the storm. Okay, so the rest of the USB is about 30 millimeters. So let's see how far that takes us. That's pretty far. Maybe we can be a little more. That was other end of this cable whacking into the water glass. Maybe we don't. I think 30. Yeah, I think 30 is the way to go. So yeah, I think we just. Let's see. So this is this is about 4 millimeters. So I think we'll just continue this all the way to here, and yeah, let's do the same thing. Let's do the same thing here. Like we'll just have this come straight out of the top. Not the most elegant, but you know. It'll work. Symmetry. I think, yeah, it'll be hidden under the disc, and it'll still be fairly close. We honestly, like, if we want to get cute with this, we could even add a little cutout for zip ties, so we could zip tie it flush against the top. But yeah, I think this is pretty good. Oh wait, what am I? Why am I having so much trouble with this? What am I doing here? Hang on a sec. Get that crap out of here. This is. We can just put this wherever we want. Yeah, we can just put this wherever we want. Yeah, all right. So now we can model in a yeah. Basically now we can model in like a little track. Well, that'll get in the way of the that'll weaken it a little bit. I don't think it'll weaken it that much though. Yeah, we can put in a little track. It tracks. Jeez, why am I having so much trouble with this? Alright. So so let's do this. Continue. Let's bring our center line to here, and let's draw a place for our USB cable to go. Construction line on. Let's draw a little curve. Let's bring it over to about here, and let's take it Let's take it all the way. Add in a few tangent. Add some constraints. Right. So you'll see what we're going to do with this in just a sec. Close enough. There we go. Okay, let's check this out. We're going to offset this by 2 millimeters in one direction and 2 millimeters in the other direction. And there we go. We now have a curved path for the USB cable to take. Yeah, there we go. Nice and easy. Let's see. All right. So the other thing we need to do is link. Let's see. The other thing we need to do is link these wires here with, like, basically the wires are going to come out of the stepper around here, and they're going to make their way in over here. So let's draw that as well. So we got our wires coming out of here. They're not very wide. They're not that wide. Let's call them 6 millimeters, give or take. Yeah, for these we'll probably want to add in some places to zip tie them down. So yeah, what do you say we do the same thing? It's gonna work. It's here. Go like so. Over here and in here. All right. And yeah, actually, dimensions don't really matter here because this is really for my use. So let's call this 3 and -3. All right, and this track is for this track is for the stepper motor wires. Can we make this tangent with this, or is it going to freak out? It's going to freak out. Over constrained. That's not what I expected. I ruined everything. All right, I think that'll be fine. So looks like this is all our dimensions that we need. Let's put this on pause and take a look at our prints. So let's first see if we've fixed all the mistakes. Let's see if we fixed all the mistakes with the inner part. Come on, get off of there. There we are. So hard to navigate. We've got so much stuff in here. We're getting overwhelmed by stuff. So let's. All right, we're gonna get confused. So I'm gonna model the old. I'm gonna label the old one 1 and label the old one 2. Yes, I want to do this even if I plan on throwing it out because who knows? Maybe I'll knock the real thing. Maybe I'll knock the real up-to-date one into the trash can. All right, so it's snug. All right, good. It's snug, but it's not. It's snug, but it's not tight, which is perfect. That'll hold it in place while we glue it to make sure everyone is where it needs to go. And here, this is a bit of a loose fit. I think I overdid it. Yeah. Stingray Master, thanks a lot for the super chat. I really appreciate it. I'm paying you because you were a good stingray. That's going to make Brooke very, very happy. Brooke loves rays. So we made this too big. Before we forget, let's go back to our drawing. And how too big is it? That's the question. How too big? A lot, actually, like a millimeter. Doesn't seem right. I'm going to change that to 5.5. Let's see what happens when we shove a... Thank you so much for the Stingray chat. Alright, so this could be a little more snug. We're going to need another nut, because I fired the last one into the stratosphere. Phrases you have heard before in a different context. Did I put all these away? Yeah, I think I did. No, I didn't? Where did I put the screws? Ah, here they are. They're where I put them. So, we've got our 10 millimeter right here. We're going to need an Allen key for this. Probably should have measured the Allen key to make sure that the Allen key fits. Yeah, I got my super nice Vera brand V. Like, is it a German W? I think so. Alright, so let's get that in there. This is our set screw. Focus, please. Let's just do a sanity check here. Get this in, tighten it against the flat. Nice and tight. Looks pretty good. Yeah, it's not going anywhere. Yeah, it's not going anywhere. I can't even with the shaft this loose. I can't force it down with my hands. So I think that's pretty good. Yeah, now that we changed that one dimension, I think we're a-okay. Let's go into the other room, trusty spatula, and pick up our TPU print. We can't. It's still printing. It says 2 minutes left. Who even knows? Who even knows? That's still printing. It's got 2 minutes left. Yeah. Cool. Okay, so let's kill 2 more minutes. Boop. Yeah. So let's save this, and I think it's time to extrude, my dude. Time to dude extrude. All right. So let's see. So we want. I don't think we don't want this thing flat against the wall, or we don't want the battery flat against the wall, because then you'll scrape your nails as you grab it. So let's start there and add like kind of a back wall to this. All right, extrude. So yeah. All right, we're gonna extrude this. You'll notice that I am extruding. Wait a second. This shouldn't. No, wait, I'm dumb. Yeah, you'll notice that I'm extruding the holes. I'm going to cut those out later. I don't want to have to, if we, oh, this has to be changed right here. If we end up, if we end up changing the configuration of mounting holes, I don't want to have to go back through like 12 steps to change it in each and every one. So yeah, it looks like when we offset, yeah, we left a tiny gap. So let's close that gap. All right, now let's get back to extruding. Extrude. It does sound a little. That word does sound a little lewd, doesn't it? It's lewd to extrude, my dude. Okay, where are we going? Oh, that's pointing the wrong direction. There we go. That works for me. All right. So the next thing we need is all right. Geez. All right. So next thing we need is to leave room for the board. I just realized something. There are going to be through-hole pads. They're going to be through-hole pins on the bottom. So we can't mount this flush against any surface. We have to prepare some standoffs. We gotta leave some relief. So let's go back to Eagle and take a quick look at that. How far are we from things and stuff? Circle. Let's see. 2 millimeters, 3, 4, 5, 6. Actually, I think this one's probably the closest. Alright, so we're starting at 3, 1, 2, 3, too much. 1, 2, 3. Alright, so we want this to be 6 and change. We can make this, can make these like 6 and change millimeters in diameter. So we'll do exactly that. 6 millimeters. Actually, I think, here's what we're going to do. We're just going to draw, some lines here, and we'll just set them to be 6 millimeters apart, and we'll just, pick the areas we want to stay, and then we will round the edges down the line. We'll chamfer them. There we go. All right. So we said about 6. So it's 6 plus we added 1, so it's going to be 7. Right? Yeah. 7. See what we're doing here? Oh, we already did that one. 7 and 7. So these are going to raise the board a little bit up. They're going to provide some relief so the pins can poke their way through. All right. Cool. So what's the next thing we got to model? The next thing we got to model is the open space for the board. So let's grab this over here. The dimensions are going to be about the same because it's more or less the same parts. So we have to leave at least, let's see, I should probably do this in a way where I can actually read the caliper. I want to buy a set of left-handed calipers. Yeah, they got handedness. You can call this 17 millimeters. We call it around 20 millimeters. Like, the thing is going to be 40 millimeters deep because of the motor. So, like, we can leave a whole bunch of, like, yeah, we can leave a whole bunch of room here. So, yeah, let's call it 18 millimeters. All right, so we're going to extrude again. So we're going to start creating the pocket for the battery to stick in. Let's see. Yep, we're going to want to leave all these open. These are, yeah, we want to keep extruding these right here. We're not going to block any of our ports. Yeah. All right, so let me think here. So we said 18. So we're going to, hang on a sec. So we're going to start from an offset plane, 18 millimeters away. And we're going, no, we're going to start at an offset plane, 18 millimeters away. And then we are going to extend, we're going to extrude to an object. We'll just pick the corner. And there we go. That makes sure that this is always 18 millimeters. Yeah, there we go. Don't want the wireframe view, it's very distracting. All right, so the next thing to do is the mounting holes for the or mounting bosses. That's what I meant. I said standoffs. I meant bosses. We'll run for a few more. Usually I'd end around now, but yeah, usually I'd end the stream around now, but we'll keep it going for a little bit longer so we can see how this thing turns out. Let's extrude. Yeah, I said standoffs, I meant bosses. I think this is enough. I think this is enough wire clearance. Let's get that crap out of here. Get him out of here. Alright. So we're going to now extrude these parts right here. And how long are the pins going to be? They're probably going to be like 2 millimeters max. 2 millimeters, yeah, 2 millimeters max. So we're going to start from here, and nope, we want to start from here, and we'll extend 2 millimeters. There we go. Now we have mounting bosses that will leave enough room in the back so that our pins don't get mashed into the the plastic. So let's go in the other. I'm just going to go into the other room and peel that TPU print off the bed. Looking good. Yeah, TPU is super easy to print. As long, once you get it, once you keep it from getting mashed up in your extruder, it's really easy to print, and it's very easy to get. Well, there we go. Easy to get really high quality stuff. It does ooze a lot, so yeah, strings are always a problem. Where to put the magnets? They've attached themselves to the motor. Strings are always a problem, but we can burn those off. Okay, so this is printed much more accurately, so these are actually a bit of a tight fit. They'll stay in with some E6000 though, and we have more room to put the E6000 in there. And then that will just that will just go onto here. The magnets will hold it in place. Hopefully the magnets are still strong through 5 millimeters of plastic. And yeah, I hope that does a good job in holding it. Let's do a little sanity check here. Let's do a little sanity check. So this is going to go in here. This is going to go on here. Yeah, it comes... Without the magnets, it comes out easily. I hope the strength of 12... I hope the strength of 12 magnets through 5 millimeters does a good job. We might want to reverse... Yeah, now that I'm thinking about it, we might want to put a set screw on the front, too. I know I was avoiding it, but... Yeah, I was avoiding it, but I don't know how else to do this. Yeah. This is the trickiest part of the project right here, is keeping the thing from falling off. Maybe we'll do a set screw. At the very least, I think this should provide enough friction. TPU is a lot more friction than PLA. So yeah. So I think this is as good a place as any to wrap up. Thanks to all of our patrons for making this happen. Your names have been scrolling in the back. Very, very nice. Let's take a quick look and see if anyone became a patron during the stream. It doesn't look like it. Oh, wait, yep. Connor Barnes, thank you so much for becoming a patron. I really appreciate it. And yeah, that's it. Thanks to everyone who contributed to the show and to everyone who tuned in. This is a bit of a big moment for me. This is, I did this stuff. This is what I did every day for 10 years. And once this project is over, there's a pretty high chance that I'm never going to. Once this project is over, there's a pretty high chance I'm never going to take another client. So this could be it. So I really appreciate everyone who showed up today. I hope you all had an excellent time. And yeah, any other orders of business? Next episode is going to come out soon. We're almost done with it. We're going to be coming back on Friday. The topic might be the same, probably different. And yeah, we're going to be printing boats and boats and boats and boats. Yeah. Anyways, I hope you enjoyed. This one was a little more cerebral than usual. And yeah. Anyways, don't want to drag this out any longer than necessary. Thanks a lot, and I'll see you in the future.